So guys, take a seat if you can. Without the presenters and the disc. Shall you? Okay, never mind. So stay there and I will call you one by one. They are shy. So just 2 words of introduction. I'm the moderator of the first session. Welcome to this workshop, which basically is 2 workshops in one. On one side, it is the 24th edition of our well-established public finance workshop that we host every year. But on the other side, there are very important twists because this year it is co-designed, co-organized and co-financed by us, but also by the IMF and Bocconi University. I would say that typically, on average, our workshop includes contributions which are more applied. Typically, they're written by, applied economists working in institutions or central bank. Whereas this year, the average contribution you will see it a little bit more academic, more cutting edge, more, I would say, also technically demanding. But this was exactly what we wanted to start with because we feel that, given the unprecedented times that we are witnessing, the new things that happen, people from policy-making institutions, we really need to get new ideas, new concepts, new findings from outside to interpret better what we are witnessing. So in a sense, we don't want to be, we practical men, we don't want to be slaves of dead economists, but instead we want to learn from researchers which are well alive and in their prime, like you guys that are going to kick off the discussion now. Now, let me switch to some housekeeping stuff. As you see from the program, we have 10 sessions plus a final roundtable. Each session is made up of 2 papers. Each one will be followed by an in-depth discussion. Presenters are allocated 25 minutes, 10 minutes to each discussant. And after that, if we all behave, there are probably 10 minutes more to, of course, to reply to the discussant, if you're the presenter, and to take some I would say a couple of questions from the floor. I would say instead that if you don't have a pressing clarifying question during the discussion, I would leave interactions for the end of the session. And now really, Anmol, you really have to come here. I guess you gave us your slides, or?
Yeah.
Okay.
Can I just...
Of course, there is the pointer somewhere on the table. Oh.
Thank you for having this paper, and thank you for the organizers to invite us. This is joint work with David, Mike, and Tom. So in this paper, so the broader motivation for this paper is as follows. In a bunch of people in this room are macro public finance people, and often we study government policies which affect social welfare or some metric of social welfare in multiple ways, especially in economies with a lot of inequality. Maybe government policies help us by reducing distortions. Maybe they distribute the pie better. So the goal of this paper is a little bit of getting a useful language for how these policies help social welfare by coming up with a procedure where if you go from a status quo to a reform, that is, if you do some reform and there is some change in whatever the social welfare metric an analyst is interested in, what component of that is coming from redistribution and what component of that is coming from efficiency, all right? Once we kind of agree on how to do this, splitting efficiency into different sources of efficiency is sort of follows automatically. For example, maybe gains coming from better insurance, you may want to carve out from gains from overall efficiency. Now, any such decomposition, or more generally any decomposition, is inherently arbitrary because there are many ways to take a number and break it into multiple numbers. So the whole thing here is what content we give to the labels and what procedure we come up with, how to assign quantities to these labels, and what properties these procedures are satisfy and they don't satisfy. So I'll give you a broad idea of like how we are thinking about what does fundamentally redistribution mean and what efficiency means. And then throughout the talk, I'll kind of formalize both the properties and the procedure a little bit more clearly. But the broad idea is that we want to anchor efficiency to notions of Pareto efficiency, which seems intuitive to us. So things like if you do a reform where you go from one Pareto efficient outcome to another Pareto efficient outcome, hopefully whatever procedure you have says that it's 100% of the gains are coming from redistribution, which we think is a very relatively minor consistency property. Maybe you go from the frontier inside the frontier, you want to say that efficiency has a negative contribution. Redistribution is more tricky, but we're going to assign redistribution to concept of a change in relative change in resources across people. Some notion of real income or real disposable income is changed across people. Whenever that happens, we want to think of that as redistribution. And there'll be other technical properties we would like, which is whatever shares we assign to redistribution and efficiency hopefully are not driven by numeraires. Going from reform A to reform B or B to A, there's some symmetry, so on and so forth, but they are less critical. Okay. So what I'll do is I'll jump directly into how we do things. I'll start a little bit abstract, and partly to kind of hopefully that it's a little bit more clear what we do in a more abstract economy, just in a conceptual sense. And then I'll do both examples and an application to an IAGARI model, a fiscal reform in a heterogeneous agent model. You want to think of that in the background, which is what has been motivating us, like monetary and fiscal reforms in heterogeneous agent economies. And all of us kind of have a sense that whenever we do those things, welfare goes up, partly because of insurance, partly because of redistribution, and so on and so forth. How do we assign numbers to it? That's the game. Okay. So the economy at the level of abstraction is more like ROW. So there's I consumers, K final goods. Each guy has a utility function UI, which maps this K goods to a positive number, and the utility functions are nice, concave, differentiable, so on and so forth. An allocation here is a list where it assigns the consumption of good K to Mr. I. Okay? So X without subscript is the whole vector or matrix, I by K, and capital letters are aggregates. So capital X is a K-dimensional vector where I've summed up the allocation across people. Production is defined by an abstract set Y, which follows standard properties. So all of this stuff should be kind of what you expect in like Maslow, Winston, Green, the standard stuff. Convex, compact, free disposal, so on and so forth. And feasibility for us is that an allocation is feasible if the aggregates lie in the production possibility set. Okay. Sometimes we like to to represent that set using a function which is negative in the interior. And I won't be using that, but in the paper we show that that representation is useful in particular applications. So at this level of generality, this covers everything. It covers deterministic economies, stochastic economies. You can have multiple sector, intermediate goods, and there are many reasons. It can cover also many reasons why an allocation might be in the interior, incomplete markets, monopoly power, taxes, borrowing constraints, so on and so forth. So it's fairly general. Okay? So think of this as part one of our primitives. Part two of our primitives is a particular welfare metric which the analyst uses. So I won't have much to talk about how to pick those. And I know this makes some people uncomfortable when we talk about social welfare metrics. In some sense, it's unavoidable when we think about optimal policy with heterogeneous agents. And in my mind, kind of the understanding how a particular social welfare metric changes and why it changes is somewhat of a different question than how to pick a useful social welfare metric and what's useful social welfare metric in a particular application. So I won't be discussing how to pick social welfare metrics. So this for me is a primitive an analyst gives. Most of the discussion, you can think of it as a utilitarian metric with some Pareto weights. That's good enough. Everything I say generalizes to more general aggregators. You can have some concave aggregation over utilities. You can measure utilities in consumption equivalents or money metric. All of those are fine. Whatever you come up with, it has to, there's a minimal consistency requirement that it has to respect Pareto improvements. That if there's a, yeah.
There's an high utility, or this is heterogeneous?
In principle.
But maybe not.
Yeah, you could. Depends. So think of the following. Imagine some examples might have it. If X has a state and time contingent goods, UI might be encoding expectations, and so expectations may depend on you may have heterogeneous expectations. Today, for now, I agree with you. For now, you can ignore that. It's not critical in the applications I'm going to study. As long as I remember, I don't think we are going to exploit that in the applications today. Okay? And now just the formal question is, we have this welfare metric. We have a status quo, which is denoted by X star. There's a reform denoted by X star star. And the social welfare, or the welfare metric has changed. How do we assign things to redistribution, and how do we assign things to efficiency? I'll start with that. Okay. So the big conceptual idea here is to come up with a coordinate system. Okay? And here is a heuristic description of where I'm going. So the idea is the following. You have all these allocations which are feasible. And what you want to do is represent these allocations in a coordinate system that's useful. And that is what gives the economic content. So what we're going to do is, for any feasible allocation, we're going to find a point in a systematic way on the frontier. And each point on the Pareto frontier will have some implicit Pareto Negishi weights associated with those. So that would be the first part of the coordinates, which will capture the implicit inequality in a given allocation. And then the fact that the allocation itself might be interior will be means that there are some wedges relative to being on the Pareto frontier, will be captured by a bunch of wedges, and some of them would be how resources are allocated across goods. Some of them might be the total amount of resources, so on and so forth. But a combination of these Negishi weights and wedges will represent a given allocation. So once we do that, or once I convince you how to do that, then most of it is just what it does. So now any change in allocation, any reform can be measured in those coordinates. You can ask, if there is a reform, what was the corresponding change in this other coordinate system in alphas and taus? And then that allows you to decompose both individual welfare and social welfare, in case that's your goal, into things which come from inequality and things which comes from distortions. So there'll be some flavor of business cycle accounting, which some people might know. think of this as not just from a perspective of a representative agent, but also thinking about inequality and heterogeneity. Okay? So I'll do it in 2 steps. The first step is, let's try to first think of the coordinate system if we are only on the Pareto frontier. This is sort of a warm-up, but it's useful to kind of start from there and then extend the coordinate system to points inside the Pareto frontier. So on the Pareto frontier, it's well known and well understood that you can represent all the points by a Negishi problem where you're summing up utilities with some Pareto weights subject to just technological feasibility. So as you, let's call these weights alpha. And as you vary alpha, you're going to span out all allocations on the Pareto frontier. So in this sense, alphas can be coordinates for points on the frontier, right? And any change in alpha would mean that you've gone from one point to another point on the frontier. And in line with my introduction, I want to think of this as a notion of as redistribution has happened. Okay. The thing, and here I don't think there's anything controversial. It's sort of, to me, obvious. What is controversial or what is harder is how do you think about points inside the frontier? Okay, and what happens when you move from a point inside the frontier to another point inside the frontier? Because that's kind of reality. We often live in economies with distortions. We never kind of, Pareto frontier is not like necessarily the most relevant thing in terms of actual reforms. Okay, so before going there, let me introduce a little bit some notation. So on the frontier, you don't not only have the Negishi weights, you also have supporting prices, which are just the tangents on those, just the Lagrange multipliers on the Negishi problem. All right. So let me think of those prices, denote those prices by P, and there will always be a 1 degree of normalization there. So they're determined up to k minus 1 degrees of freedom. Okay. Once you have those prices, you can map an allocation into a notion of disposable income, which is just what is the value of your allocation at those prices, which we call YI. And the sum of YI is aggregate income. Okay. Maximum income here, this is just a set of objects which I'm going to use. Maximum income here is what is the highest income this economy can generate from all feasible allocations. So that's Y max of P. And finally, I'll use VI, P comma YI as an indirect utility function, which is just the maximum utility a household can attain given those prices and a particular level of income YI. Okay. So think of the last bullet point as a problem which allocates goods across households, and the one before as a problem which allocates which figures out the total amount of income. So now let's go back to this idea of pinning down a coordinate system. Okay, so we want to think of how to pick a point on the frontier and a bunch of wedges to represent an allocation. So here is the main theorem. So for every feasible point x, there exist coordinates alpha, psi, and tau, such that the following 3 conditions hold. Okay, and these conditions are going to give sort of meaning and interpretation to those coordinate systems. So before I go, let's just make sure we have the dimensions correct. Alpha would be I minus 1 dimensional object, sums up to 1. Xi will capture deviations from total income, so or how far we are, how much income the economy has at some implicit prices relative to the maximum income this economy can have. So it's a one-dimensional measure of production efficiency. And then taus would be person good specific wedges that describe the allocation that describe how the goods are allocated for each individual I, and they are defined for k minus 1 times I coordinates. Okay, so k minus 1 times I plus 1 I minus 1. So these coordinates have the same cardinality of x, and the way these coordinates would work is xi would be a notion of production, a notion of overall efficiency. Alpha, the coordinate alpha, which I defined as this implicit Pareto weights, is sort of saying what point on the frontier has the same income distribution as the point inside the frontier at the supporting prices. So it solves this problem, and taus represent just wedges in the first order conditions of Hausdorff. So the point of this coordinate system, there is a lot of technical stuff in the paper. When does it exist? When it's unique? And I'm going to skip that. But the point of this coordinate system is that you can go from allocations to these coordinates and these coordinates to allocation 1 to 1. Or if not, there is a selection rule which is about 1 to 1. Right? So that's the content here. So now, once we have this coordinate system, we can represent welfare not just as a function of the allocation, but directly in the space of coordinates. Okay? And that's sort of the basis for our decomposition. Okay? Just to start off, points on the Pareto frontier would be alpha and 0 for all the wedges. Whenever you add wedges, you'll reduce welfare, and that sort of gives interpretation to the coordinates other than alpha, taus, and xi's as measures of efficiency or efficiency losses. So far, what we have is a coordinate system for all feasible allocations, and now the question is, what do you do with that coordinate system? You can do two things. You can measure the contribution to individual welfare by just asking if there's a reform. Let's start with a small reform, and I'll do the global version in the next slide. But let's start with a small reform. A reform here means you go from X star and you change the allocation in a direction X hat in a small sense, in an infinitesimal sense. So now X hat is the reform, and this reform will induce a change in the coordinates, which is alpha hat and t hat. We can ask how much of individual welfare now, which comes from allocations, comes from a change in alpha hat and comes from a change in t hat. Okay? You can also add up these individual contributions and ask how much of the social welfare metric changes because of alpha hat and because of t hat. And our proposal is to pick the share which is coming from alpha hat relative to the total welfare as fraction attributed to redistribution, and the residual fraction which comes from t hat in our case, we'll assign that to efficiency. So that's kind of our proposal for the decomposition in an abstract sense. In a little bit, I'll also show you how this component maps to actual policies in a competitive equilibrium. But so far, everything has been developed here is just in the space of allocations and with respect to just primitives like utilities and production possibilities. Okay? Just a quick note, sometimes reforms are not small, they are big. And there we have to take a stand in how to, things are nonlinear. So our preferred way is following the standard Shapley-Shorrock's type decomposition, where the idea is the same. You want to figure out redistribution is always the change in welfare which comes from the alpha coordinate. Now you have a choice where to measure it. Do you measure it at the original allocation? Do you measure it at the final allocation? A Shapley decomposition would say, do it at both and take the average. So that's kind of what we do. There is no, you can do some other things. That's, in practice, these details matter less. So here is a set of properties which our decomposition satisfies. So by design, it satisfies the Pareto consistency properties that I started off with. points which are just on the frontier will have only contribution from redistribution. If you are on the frontier and you go inside, you'll necessarily have a negative efficiency contribution. Both of these are easy to see, given the way we actually constructed the coordinate system. Besides that, there is numeraire invariance. The shares don't depend on which good you call the numeraire. There is direction invariance. You go from X star to X star star or X star star to X star. You're just going to flip signs. The more important and possibly the property where there is more of a stand we take is what's redistribution. And that's the last property, that redistribution happens when there's a change in the distribution of real incomes, which is at star P, at prices P star, you're asking what is the value of the allocation you had and how much it changed. If the distribution of that doesn't change, we will say there is no redistribution. Okay, and to us this aligns with how economists and we have thought about redistribution, that for redistribution to happen, some resources should go from me to you. Okay. You can see quickly that once you can do this procedure extends more generally. You can break down the wages into allocative wages and production wages, as I had done before, and just keep on doing the Shapley decompositions and get further and further into further in components of efficiency. Similarly, by relabeling goods by states and physical goods, you can get a part which is coming from insurance and a part which is goods related. So all of the decomposition extends, the properties extend. You can also do aggregate shocks, idiosyncratic shocks. All of that goes in a way you would expect it to go. You also get nice expressions where insurance components align with changes in exposed risk, adjusted by measures of risk aversion or risk neutral probabilities when there are aggregate shocks. So before doing the applications, I want to kind of show one more representation of this decomposition, which might align to, which will make it slightly less abstract and align more, a little bit more to the public finance literature on deadweight losses and lump sum transfers and stuff like that, which I think a lot of us get intuition from. So on a basic level, you can also think of an allocation as a competitive equilibrium with a fictitious set of instruments. So if you have a rich enough set of instruments, lump sum transfers indexed by people, goods, commodity, taxes which are indexed by I and K, production subsidies, government spending, that gives you enough flexibility to pick any feasible allocation and say that implicitly there are some taxes, transfers, and all of these instruments, so that so that the standard competitive equilibrium holds, and whatever allocation you are thinking about is an outcome of those policies. Okay, and there the notion of a competitive equilibrium with these fictitious policies is standard. Households maximize given these instruments, firms maximize, and a government budget constraint holds, where there would be two types of taxes the households pay or receive: lump sum transfers and commodity taxes. There would be taxes given to or paid by the firms, and potentially government spending to capture the idea that you might be inside of the PPF. So some notion of waste. Okay. Given this, we can equivalently state our decomposition in terms of if an allocation has changed, maybe implicitly these policies have changed. Okay, so I won't take you through the details, but I'll give you like a simplistic version of that representation, where I think the intuition is clear. There are more and more complicated versions with more and more terms, which become, which are all interesting, but for lack of, because it's a short presentation, I want to get that. So let's take a simple case where government aggregation holds. So this P of alpha doesn't depend on alpha. Okay, this will be true if preferences are UI and satisfy standard government forms. And also, let's think of allocations which are on the production possibility frontier, so there's no wastage. So just so that I isolate fewer terms. So in that case, there are two sources of, so there's one source of inefficiency, which is now, you are on the PPF, so the only way you can be inefficient is if you misallocate goods across people. So commodity taxes are non-zero. And redistribution can occur because taxes and transfers, or net taxes and transfers, may be positive for some and negative for some. They have to add up to zero, given that there's no wastage in this economy. So what are that abstract decomposition in this Arrow-Debreu economy? If you apply it here, what it picks up is the following. It picks up the redistribution component is basically the sum of net taxes, weighted net taxes paid by households, and the weights are marginal utility weights. That's because this is going back. This is adding up to social welfare, adjusted by 1 over 1 minus eta I, where eta I is weighted income elasticity. Okay, I'll say a little bit about why it looks the way it looks, but for now, think of there are social welfare weights, alpha bar I, there's marginal utilities, there is income effects, and then there is, in redistribution, there is net taxes paid and received. For the efficiency component, you're going to have compensated elasticities multiplied by the change in commodity taxes. So people who come from Diamond Murleys and those kinds of framework will recognize that deadweight losses are sort of given by this compensated elasticities or they're relevant for the amount of deadweight losses and the primitive change in taxes. And this is again added up using income effects and the social weights. Okay. So why do they look like that? So the fact that, let's start with the right-hand side term, the sum K over compensated elasticities time change in commodity taxes. So that's basically Harberger's triangle. If you think of starting from an efficient economy, the weighted in compensated elasticities have tax payments in it, and the last term is basically adding up Harberger triangles across people. The reason income effects show up is whenever you take $1 from I and give it to J, their spending changes. When income effects are non-zero, if their spending changes, their payments on commodity taxes changes, and that has to be, then you have to redistribute that too. So there is like a loop which is resolved by 1 over 1 minus eta I. Okay, so it's in some literature it's also called the fiscal externality coming from income effects. Okay, so how much time do I have? Okay, so let me just give a very brief overview of the applications we intend to study. It's surprisingly hard to actually get a decomposition which satisfies these properties. We didn't think it was a very high bar, but it turns out that it's hard to satisfy that. And we kind of try to contrast that by looking at two well-known decompositions which people used in the literature, Benabou-Floden and Davila and Schaab. And it turns out that both of them don't satisfy even the first two properties that we put forward. Okay, I think I'm running out of time, so I'll skip the example and go to the application, just to give a flavor of how this decomposition can be used in practical problems. So this application is not novel. It's a very standard application. It's a standard Iagari model calibrated to the US, and we are looking at a fiscal reform where we change, there's an affine tax system. We're changing the slope of that system and doing adjustments using lump sum transfers. And the notion of welfare here is welfare including everything which happens on the transition, okay? So imagine you did one of these reforms and you ask what happens here. What is the welfare gain, and what fraction of it comes from efficiency, what fraction of it comes from redistribution, and so on and so forth. So in this particular case, I'll do a reform which goes from 30% marginal tax to the optimal utilitarian number, which in our calibration comes out to be about 50%, 48%. And what I'll show you is a couple of numbers and a couple of pictures that explain how this reform is decomposed with our metric. So just in terms of high-level numbers, what we find is that the reform affects welfare through all the mechanisms which we expect it to do. Redistribution accounts for 68%, insurance accounts for 124%, and there is a negative 92%, which comes from goods-related efficiency. And the biggest culprit in the efficiency is the within-period consumption leisure distortions. The fact that this reform improves intertemporal smoothing or can have some effects on the level of interest rates or capital labor ratios, those kinds of effects turn out to be small. We also tried to ask what taxes you would pick if you purged out the redistribution gains from overall welfare. And yeah, the taxes are lower, but not that much. So they go from 48 to 43%, which gives you a different metric of thinking about how important were the gains in the original welfare metric from redistribution. Like how much would you deviate? The person by person decomposition means we can actually give you a distribution of these components. And one convenient way to group them is to bin people by income or wealth and ask within each group who is gaining, who is losing, and whether the gains come from which component. So this picture or pictures like these can be produced pretty easily given everything is additive across people. And an illustration of this, at least in this economy, is that there is poor people win here. This is fundamentally an increase in redistribution. And rich people lose. The gains come on the left for the wealth poor people. The gains are roughly equally split in redistribution and better insurance. Insurance is the green thing. It's positive for everybody, which makes sense. And the efficiency losses are concentrated in quantile 3 and 4. Again, as I mentioned before, most of the efficiency losses comes from the distortion on the within period distortion on labor supply. Okay. I think I'll stop here.
Thank you, Enmo. And now it's the turn of your discussant, which is Professor Pavoni.
Okay, so let me just quickly go. I mean, as he explained, the goal is to decompose these welfare effects to policy reforms and in between redistribution and this is like a question that raised in the last 25 years after Benabou. I think it's an important question because precisely, as the last picture shows, you really would like to understand the effect of different reform in a rich way. Okay, what I already explained is like decomposing some coordinates. The first coordinate, the alpha, are associated to redistribution, whereas there are wedges, including insurance. Okay. You explain, let's I would like just to stress that this decomposition has this property that I would like to stress. There are more on that. First of all, there is no efficiency gain if two allocations are on the Pareto frontier. If one is on the Pareto frontier, the other is not, there are efficiency losses. Those two properties, that's so simple like that, they are already an achievement. There are very well-known, I will discuss quickly, approaches in public finance that actually don't even meet the first two bullets, okay? Then the second one, so is, seems to be trivial, minimal requirements, but sometimes they don't. And then, of course, they have this idea of income-based distribution that essentially is like a sort of the flavor of their decomposition. But let me go a bit, at least the way I understand how it's going. Okay, then, of course, as explained, the efficiency part can be refined further between production, insurance, and good allocation. My view, this is more a question to try to understand how it works or not. So let's start from something that maybe is more familiar to some other people, the compensation principle action. So, the other point is that I should have an next slide earlier, because what I really, I'm not the guy that need to please something for nothing. I really like the paper very much. For once, I said, oh, good. We can really, understand how all these concepts, sometimes when you were trying to understand the concept of redistribution, or whether the efficiency gains, you switch from a macro model or theory, and then you do this back on the envelope calculation. You don't really know how they are related to the utilities or this kind of stuff that are applied stuff. Let's do it. A completely different word. You just jump to a different word that applied people do. Here, I think this paper create a link, so at least allows me to understand. One famous approach is the compensation principle. Say, how can we detect whether there are efficiency gains? Well, they are positive whenever the losers, if, of course, there are all gaining, there is a positive. But, in non-trivial situations, there may be losers and winners. Okay, and so we can say they are positive whenever the loser can be hypothetically compensated by monetary transfer by the winners. Very simple sentence, right? Well, monetary transfers. So, but how much money you have to give? So in principle, what are the prices? This is a famous, approach, but the question is, what are the prices? In the practical terms, sometimes you use prices they observe, or the prices that are arising from the distorted economy. Well, it's well known, but which prices are you using is not innocuous at all, obviously, right? Many times, in fact, you don't even, you make this sort of simplistic assumption. Let's suppose they are quasi-linear utilities, so they can really allocate this numeraire across people. When are we in macro using quasi-linear utilities? I don't know, Okay, so the relevant prices. Of course, the relevant prices is not an obvious way. Okay, what they are suggesting, I say, look, we have a way, at least, to have a hypothetical. You can complain with this choice, but for sure, those are prices that are for everybody. What are these prices? Well, they are computed by an hypothetical Negishi-like planner that are multipliers associated to the resource constraints. Of course, this requires to define what are the resource constraints. For example, there wasn't a formula before. Another way that people use it is using as shadow prices the individual marginal institutions. But these, are distorted stuff, right? They are not really prices, they are individual prices. So, these one at least are proper prices in a hypothetical economy, but that. The second difference to me is also the approach that they call income-based redistribution, essentially to say, okay, what is the other typical, all other, including the Breuer approach, what is the allocation telling us? The natural way is to say, okay, the allocation is giving us the utility of the guys. So let's move from there. They say no. Before that, given that we have the prices, we can say, well, the allocation is giving us the disposable income on people. And there is an advantage, or at least the approach is different, and let me explain why. I go a little bit in the details. There is a feasible this allocation gives you total amount of resources, right? So you can use this pseudo planner with the Kuntaka multiplier associated to them to get the prices. Of course, sometimes you require a fixed point problem, but this is a technical issue, of course. Even with these prices, what Caldor X would do? Fantastic. What I do, I have a price, I can associate it to the utility, which is the utility coming from the allocation, an indirect utility. So by doing this, I have a price, I have an indirect utility associated to it, I have a monetary, a sort of disposable income associated to it. Okay, then what? Well, there is another allocation. I can do the same as the size. Suppose the prices don't change, whatever. Say, in this case, of course, sometimes they change, but at least we have a case in which they don't. If the aggregate resources are the same, we know that the price will be basically the same, okay? Even using these prices, even with these idealistic prices, what can we do? What is the redistribution? What is efficiency? We are starting from this point with these individual incomes. We don't know which one are, Here, there is a very simple way. Don't associate to the allocation the utility, hence the associated income to the utility. No. Let's go to the frontier. Let's associate the disposable income and associate the potential indirect utility. That's not the utility that people get, because this is what you would do if you had this income and you would do the best. So this is how you use the allocation to essentially define redistribution with the prices. And then, of course, these differences in disposable income are a measure of the redistribution. Actual utilities now are not associated with an income, are inside the indirect utility because they are not using this income efficiently. But then, of course, you can account for with wedges between this difference. So that's, the way I see, their approach. Okay? I repeat, the same problem is the coefficient of resource utilization. Even the Breu say, look, I have an allocation. This allocation tells me the utilities, and I draw an hypothetical Pareto frontier passing through these utilities. You don't know how to decompose it. If you start saying the allocation gives me an utility, you don't know how to move away from it. So you can play whatever you want. Okay, that's, I think, what I like. But, okay, these are details. I don't think you want to go into that. Okay. The quantitative lesson I also want to skip. So let me just say a little bit what I like. Is the language. That's the target, of course. I think it is important to have a language. People have been trying. This is one of them. There are other papers that are interesting as well, complementary to that. To me, at least as a macroeconomist, is a clear, very intuitive and transparent known concepts. So at least I understand what is going on. And the second one is this idea that by doing the negotiation approach, by having this disposable income out there, you have automatically maybe subjective, because I do macro public finance, but there is this natural decentralization. There is this natural way of saying, first you have net transfers, the second way you can move across allocation with net transfers, then you have production inefficiency, you think about wedges in producers, some waste resources, and then of course wedges within the misallocation and marginal deadweight losses. So, this is something that say, okay, you give me what they want, that's it. Of course, maybe other people want different ingredients, but at least to macroeconomists, those are the ones they would need. So comments, just the last slide comments. So first of all, you do already in the decomposition. It's true that with ex-ante identical people or a continuum of people, this is not really a vector, but you have numbers for each individual. Why I give an aggregate? Just give me the vectors of changes, and I choose the alphas myself. And, the outcome is similarly for efficiency. You can do the same, and then the aggregation is done differently. Because in fact, of course, the fact that these alpha and alpha bar are kind of different things can confuse some readers, I would say. Okay. Again, this idea that these measures are measure of welfare may upset or not really make clear the connection, but you can do it. So it's better to associate with these measures also what people like, consumption equivalent or whatever, after you did. Of course, it's non-trivial. There is a technical aspect. There is a fixed point to be calculated. Sometimes it's easy, sometimes it's not. And for applied people, I don't know if you have already a code available online. Okay, so it would be important to understand whether this procedure is robust to situations like that. Of course, the other point is that all these work super nicely because we are working in concave preference to convex economies, right? And all these arguments I was saying, the decentralization, without that is all. But that's again for a macroeconomist, I say rarely using non-concave situations. But this is all to be done. Not clear whether it works or not. Then I have a last question. In-kind policies, like public education or childcare housing, how do you classify quality changes, targeting changes? I don't know whether you would say that's production efficiency, subsidies, or maybe something else. I don't know. This is potentially another exercise you can think about. Okay, that's it.
I can take questions and then come. Yeah.
I was wondering about two extensions. One is the dynamic model. Can you just use geography analysis or the dynamic setting?
Yeah. So the Ayagari model is dynamic.
Yeah. And the second one is what's called asymmetric relation.
Good point.
Do some
Good point. Jim, I'll take your question and.
Yeah, Jim Bullard, Purdue. I love the paper. Thought it was really great. As you know, I like to do OLG models. So now we've got young people and middle-aged people. Everyone has the same preferences. It looks like your social planner wants to reallocate to the young person because the marginal value of an additional unit of income is higher for them. But I already have the social optimum in the model I'm thinking about, so you actually wouldn't want to do that. So that sounds like a little bit of an inconsistency for what you've got.
I'll explain that. So, any other questions? All right. Thanks a lot, Nicola, for the great discussion. Let me quickly make one or two comments on the points you raised. They're all very useful, and we do think of this paper a little bit as a language paper, so that these words are grounded now in certain properties, certain axioms. There are a lot of connections to what De Bruyne did and Harberger did, and one thing I want to make sure so that it doesn't misinterpret other people's work is that a lot of literature, starting from De Bruyne's 52 paper, Harberger 71 paper, and so on and so forth, they had a different mission. They wanted to come up with one single metric of efficiency, and so that it's easy to communicate, easy to calculate, maybe used in some cost-benefit analysis. And there were different proposals. Now, that's one idea, where it's kind of devoid of social welfare functions. Just what is a metric of efficiency? I think it's a fine and a different exercise. What happens is a lot of issues we saw in the literature were trying to use those measures, which were developed for an independent reason, as a way to decompose welfare, given a particular social welfare metric. So when you merge these two agendas, I think, at least in my sense, you end up with a little bit of inconsistencies, and that is my understanding of why those Benabou and all of that stuff doesn't work well. Your point about in-kind transfers is great, and we are thinking about it. Another example, just going with the list you had, is also climate and externalities. I do think we can fit that and maybe having some applications or would be good. So asymmetric information is a good question. We haven't thought much about it. So at this point, it would look like somewhat of a. It would be inside. Given the Pareto frontier is defined just on technological efficiency, it would look like a point inside, if it's driven by by asymmetric information or other agency frictions. But I think it's a great extension where maybe the set Y is defined subject to those agency frictions. So that gives us a different point of comparison. Like maybe you want to split we want to call it inefficient as things which are strictly constrained inefficient, separately from just technological efficient. We haven't done that, but I'm very happy. This is a great point. Jim, so whether you want to give money to young people or not depends on your social welfare weights. It's unclear that, so if you take an abstract social welfare function, it's not implied that you want to give money to people who have high marginal utilities. You can offset that by Pareto weights. In fact, you can construct social weights such that there's no gains from transferring money from one person to the other at some status quo location. So it ends up being, so this is kind of a stand we had taken in our paper when we did optimal monetary policy, where we asked what social welfare weights, so it's a kind of an inverse Pareto optimal question. What social welfare weights do we need so that observed tax policies, how much we tax income, how much we tax wealth, how much we tax returns on wealth, are actually optimal. So that's how we constructed the social welfare function, that if nothing happened, if there was no aggregate shocks, there was nothing for anybody to do.
All well and good, but when you get to act classifications, people are going to want to say equal for everything.
That would induce those kinds of issues, but that's kind of, at that point you've committed the sin. Any other comments, questions? Thank you.
Thank you. Now we can switch to the second paper of the session. The presentation will be delivered by Professor Ferrier.
So thank you for having the paper in the program. This is joint work with Philippe Grubener from WashU and Dominique Sachs from St. Gallen. So in this paper, we want to think about the sort of the long-run key determinants of the optimal level of redistribution in a country. So of course, one of the first things that come to mind would be income inequality. And as you all know, the US have experienced a large increase in income inequality since the 50s. And this rising inequality has become a central argument in the policy debate to call for more redistribution. And the argument is very standard, is like the US should redistribute much more now than in 1950 because there's so much more inequality now than in 1950. And that kind of argument is in line with the predictions of the workers' models of optimal income taxation. And by that I mean models in which you have an exogenous distribution of abilities and endogenous household decisions, such that the optimal tax schedule emerges as the response of a trade-off between efficiency and inequality. Okay, but over the same time period, the US also experienced a very large increase in their standard of living. That is, income per capita more than tripled, and the spending share, the share of expenditure spent on necessities fall dramatically. I'll show you numbers later. So in the workers' model of optimal income taxation, these rising living standards have just no effect on the optimal tax and transfer system. Why? Because they're homothetic, so the size of the economy is irrelevant. Yet one may think that, like the distributional gains from distributing resources from the rich to the poor may be very different in an economy where everybody is very poor or in an economy that's overall much richer. Same thing is true for efficiency cost of taxation. So in that paper, what we do is very simple. We study like an optimal income taxation problem à la Merlis, but with non-homothetic preferences. That is, we're going to use preferences that feature heterogeneous income elasticity of demand across sectors. And in particular, we focus on the two sort of what have become the two state-of-the-art non-homostatic preferences in the structural change literature. So for today, I'll focus on the non-homostatic CES of Comyn, Lashkari, and Mestieri. And in that setup, we are going to be interested in understanding the changes in the level of the economy, which will endogenously generate a fall in the share of expenditure spent on necessities, which is our concept of rising living standards. Okay, and then we are going to do two things. So first of all, we are going to just formalize the effect of rising living standards on optimal taxes. And for that, we are going to build on the formula of Fiscal and Tsujiyama that give us a way to disentangle distribution versus efficiency concerns. So just to link it to the previous presentation, it's not a decomposition of welfare, but it's really a formula that tells you that the optimal tax for each household should equate the distributional cost of the distributional gains of the tax together with the efficiency cost of the tax. And then if you change something in your environment, you can change efficiency or redistribution gains, and you can check which one are sort of more important. And then, so once we've done that, we are just going to quantify the relative effects of rising inequality and rising living standards. So here, the way we are going to work is as follows. I'm going to start with an economy that I'm going to calibrate to the 50s. And here, I'm going to adopt an inverse optimum approach. So I'm going to say, what are the Pareto weights that make the observed 1950 tax and transfer system optimal? And then I'm going to assume that these weights are given. And then I'll move to 2010, and I'll compute my optimal tax and transfer system first when I only account for rising inequality, and then also accounting for rising living standards. Okay, so very, very quick preview of the findings. So first of all, I'm going to argue that non-homostatic preferences do feature increasing IES, or decreasing relative risk aversion. And this property, this DRA property, is going to be key to understand the effect of rising living standards on optimal taxes. So rising living standards is going to affect both distributional gains and efficiency cost of taxes. So let me first explain the distributional gains. So rising living standards is going to have an effect on marginal utilities. So think of an economy in which you have a given level of relative inequality, and that economy is overall very poor. So the poor in that economy are going to consume mostly necessities, are going to be, think of it as very close to their subsistence levels, they're going to have a very, very high marginal utility as compared to the rich. Then take this relative inequality as given, but assume that the economy is getting overall much richer. Okay, so the marginal utility of the poor is going to shrink much more than the marginal utility of the rich, so that the dispersion of marginal utility is going to become much smaller. What it means is that the distributional gains from taking resources from the rich giving to the poor is going to become much smaller. Okay, so this, in fact, is going to be quantitatively the main effect of rising living standards on the optimal tax and transfer redistribution. And so overall, the rising living standards are going to call for less redistribution, and that's going to matter quantitatively significantly. I'll show you a number. Okay, so let me skip the literature and start with, I want to show you that non-homostatic preferences, so something about intra-temporal allocations, do imply that preferences feature increasing IES or decreasing relative risk aversion. Okay, so consumption patterns across goods do require non-homostatic preferences. So here I didn't even put any graph or references, but as you all know, the shares of expenditures spent on food is falling over time or falling with income in the cross-section. That's a very robust finding. So there's this old theory literature which has already shown that if angle curves are nonlinear, then it just cannot be that preferences feature constant IES or constant relative risk aversion. Okay. So what we want to do is we want to go one step further and say that then preferences actually feature increasing IES. So what is the intuition for that? So the intuition, in a sense, is very well summarized by the title of a paper by Browning and Crossley, which is just saying that luxuries are easier to postpone. So the idea is that, for instance, as explained in the first citation here, is that if you consume, if most of your expenditure is spent on luxuries, then it's not very costly to postpone consumption between today and tomorrow. Like you can go to the movie today, you can go to the movie tomorrow. If instead most of your expenditure is spent on necessities, then it's actually very costly to postpone consumption between today and tomorrow. You can make the same type of argument with risk. It's done in a paper by Duflo. Okay, so this link between intra-temporal allocation and this increasing IES or risk aversion, I'm going to document it first in the data, and then I'm going to show you how it works in theory using non-homostatic preferences. So in the data, first of all, there's really very many papers that point towards increasing IES or decreasing relative risk aversion. coming from really very different angles. So you have papers that look at risk sharing in Indian villages, papers that do Euler equation estimation using UK data. There are papers looking at portfolio choices and so on and so forth. What we do here is very simple. We take two of the recent papers that do Euler equation estimation to estimate the IES. And what we do is that we check whether the food share, the share of expenditure spent on food is actually informative of the IES. And when we do that, what we find is that systematically that the high food share household, so household with the share of food spent on expenditure, share of expenditure spent on food above median, actually systematically have a lower IES, okay, or a higher risk aversion. Okay, you can do more in terms of data, and you can look at, for instance, consumption volatility, and we find like similar findings, but I'm going to skip now. Okay, so this link between so food shares and IES, it's something that emerges naturally from the recent non-homothetic CES preferences. So let me maybe quickly introduce you these non-homothetic CES preferences in case you are not familiar with it. So those preferences, they depend on a consumption aggregator C, which is not, which you don't have in closed form, but which is implicitly defined by the equation here. So what you can see is that, so this equation here depends on a few parameters. Sigma first, which is going to capture the elasticity of substitution between goods. And then the epsilon j, which tell me which are going to govern the income elasticity of demand for good j. So what you can see is that if epsilon j is low, then it means this good is more of a necessity, and if epsilon j is high, it's more of a luxury. Okay, so abusing a bit notation, you can use the budget content of the household to define this aggregator C as a function of expenditure of the household and the vector of price. Okay, so you can find the C that's going to maximize, you can define C as a function that maximizes this aggregator given the household's budget constraint. Doing that, you can then compute risk aversion. And risk aversion, you can express it as follows. So it has two terms. So first of all, a first term that has the gamma, which is the curvature of my utility function, times a fraction that tells me the elasticity of C, my aggregator, with respect to E. And then it has a second term that has to do with elasticity of CE with respect to E. So first of all, here, what you can see is that this, of course, is going to retrieve the standard homothetic case. So if you are in the case where all epsilons are equal, then you can show that your aggregator C becomes linear in E, and so the first fraction is a 1, the second fraction is 0, and you're back to your standard thing. But as soon as you have differences in your epsilons, you can show mathematically that this fraction here, this elasticity of C with respect to E, is actually falling in E. And that, again, is pretty intuitive. The intuition is as follows. So if you consume mostly necessities, if I give you a little bit more of expenditure, that's going to increase your aggregator consumption by a lot. If instead you consume a lot of luxuries, giving you a bit more of expenditure is going to increase your C by a smaller number. Okay. So this is really what's going to give me the force for DRA. The second term is actually, so the second term about the elasticity of CE, that can take any sign, because those preferences are very flexible, but that's typically very small. So I'm going to ignore it for now. Okay, so what does it mean for the quantification of this link between sort of intra and intertemporal allocation? It means that, so I have a lot of cross-sectional data on consumption shares, and I'm going to use that to estimate all of the epsilons which govern the response of C to E. And that's not me who does it, that's done in the paper by Comin et al. And then I'm left with only one parameter, gamma, that will discipline both the level of risk aversion or IES and the degree of heterogeneity of IES across households. Okay, so I'm going to come with a calibration in which my gamma is going to match basically the numbers I showed you earlier. Okay, so now that I have this link from non-homothetic preferences to DRA, let me move to my Merle's model. So I'm going to have a very, very standard static Merle's setup in which I have a continuum of households with productivity theta. They choose how much to work, N. Then I'm going to assume separable utility over consumption and leisure, where I'll have standard isoelastic labor preferences, and C is going to be my basket of goods. And I'm going to denote an indirect utility function, U, which depends on expenditure E, which will just tell me what is the maximum amount of utility I can generate given my level of expenditure E, such that the household's budget constraint holds. So for notation here, I'm going to have a vector of price P, okay, and I will separate it between the vector of relative price p bar, and for now I'm going to keep that constant, so I'm going to drop it, and lambda here that will capture the level of the economy. So here I'm going to think of an economy that is bigger when the overall level of prices is falling. Okay, so prices become cheaper, and therefore the economy is richer. Okay, so the household's problem then is also very standard. The household is just maximizing this level of expenditure and labor supply in order to maximize its utility given the tax set by the government. And here you can see that in the little u there's an homotheticity that's hidden, but it looks like a perfectly standard Merle's problem. Okay, and then therefore the government is also very standard and has this maximization problem given a distribution of Pareto ways, W, which can take any shape. Okay, so I decided to spare you the equation that shows the optimal tax for each household, like equating efficiency cost of taxation to distributional gains. But the formula of Hitchcock and Tsuriyama tells me that the efficiency cost of taxation essentially depends on the free elasticity and income effects of each household. And income effects, they are going to change as the economy is getting bigger. Distribution gains, they are going to depend on marginal utilities of expenditure, which again are going to change as the economy is getting bigger. And of course, you have allocation in the background that can also change as the economy is getting bigger. Okay, so the first thing we do is that we go back to the homothetic CRA benchmark, which means that we assume that all epsilons are constant, and therefore we are back to the usual utilities. And here we can show that when your economy is homothetic, the size of the economy is irrelevant. So in a sense, that's very good news because that's what the assumption we do all the time. We always use homothetic benchmarks. We never think about the size of the economy, and in fact, it's good because it's irrelevant. What we show more specifically is that both the distributional gains and the efficiency cost of taxation are insensitive to the level of the economy. And it doesn't mean that the level of the economy does nothing. In fact, like if the economy gets larger, for instance, people may start working less. But they would do so in a way such that expenditure and income distribution remain constant, and optimal marginal and average tax rate eventually become constant in theta. Once you move away from the CRA and you go to your non-homothetic utilities, preferences become DRA, and that's going to have effects, maybe I should do this first, both on efficiency cost and distributional gains. So distributional gains, I already explained that in introduction, that is going to have to do with the distribution of marginal utilities. As your economy gets bigger, the distribution of marginal utilities is going to shrink, and therefore you want to redistribute less because you have less gains from redistributing from the top to the bottom. But that's not the end of the story, because income effects are also going to become weaker as the economy is getting larger. And this has ambiguous effect on the efficiency cost of taxation. When your income effects become weaker, it becomes harder to raise taxes on the rich, but it's become less costly to give transfers because the poor would decrease their labor supply less. Okay, so that in principle is ambiguous. And there's a third small effect that I'll skip for now. So overall, the effect of raising living standard and optimal taxes is ambiguous and goes both through distributional gains and efficiency cost. And in principle, we cannot sign it, except in the very particular case, which is the laissez-faire that Anil discussed earlier, which is like you can take an economy, and at a given level of lambda, you can always find a distribution of Pareto weights such that you don't want to redistribute anything. So starting from this laissez-faire economy, what you can show is that a marginal increase in my level lambda has to imply that the optimal tax and transfer schedule becomes regressive. You start taxing the poor to give to the rich. Okay. Generally speaking, going away from this laissez-faire, you cannot sign. So what we do then is that we go quantitative to see how the whole effect work together. So to do quantitative, we have to do a bit of a calibration. So we are going to have to calibrate two economies, which is 1950 and 2010. I'm going to work with three sectors, so like food, goods, and services. And I'm going to have to calibrate growth, preferences, and then government and inequality. So growth is going to be very simple. I'm going to have to calibrate my economy such that the overall fall in prices is going to generate a growth of income per capita of 3.3, which is what comes from NIPA. But I'm also going to account for the fact that the relative prices have changed over that period, and in particular, services has become relatively more expensive. Okay, so I'll account for that, and at some point I'm going to show you decomposition of whether this matters, or to which extent this matters. Then for preferences, so we are using the income elasticity of demand, which have been estimated in the paper by Comin et al. And that is going to generate changes in sector shares, which are in line with the data. Very importantly, for the rest of the preference parameters, so we need to take a stand on this consumption curvature parameter gamma, as I said earlier, and we are going to find a gamma which matches both the level and the heterogeneity across IES for my two groups below and above median. And what you can see is that we are kind of conservative. We are having a degree of heterogeneity that is relatively small as compared to what we had in the data. Okay, for the rest of my calibration, so I'm going to approximate the tax and transfer function using a cubic polylogarithmic function to match transfer to output ratio as in NIPA and moments of the marginal tax rate distribution from the paper of Kirill Mertens. And I'm going to do that both for 1950 and then for 2010. And finally, for inequality, I'm going to follow a partial insurance approach in order to match variance of log expenditure. Okay, so with that, again, what I'm going to do is that I'm going to quantify the effect of rising living standards. So first of all, I'm going to go to 1950 and do my inverse optimum approach. So I'm going to find back out the Pareto weights that make 1950 optimal. And then I'm going to add inequality, and then I'm also going to add rising living standards. Okay, so let me show you what it means in terms of marginal rates. So this is the marginal rates as a function of income, and one is mean income in 1950. So this is what I get from my calibration, so that's the status quo, and that's optimal by construction. Okay, then I just feed in the rising inequality by increasing the variance of log expenditure. And what you can see is that suddenly you really want to increase your distribution by a lot. You want to increase marginal rates at the top and decrease marginal rates at the bottom. Overall, you raise more revenues and you redistribute a lot more. I'm going to show you average rates in a second. But then when you also account for rising living standards, or growth, as we call it sort of in a loose way, you actually reduce by quite a lot this initial increase in the marginal rate. So you still want to redistribute more in 2010 than in 1950, but by much less than what you would do if you would only account for the story about inequality. So if I translate that into average rates, which maybe is more telling about the amount of redistribution. So I'm going to show you the average rates of the bottom 30%, of the top 30%, and I'm going to call R sort of a redistribution measure, which is just the difference between these two numbers. So this is what you get in 1950. In 2010, if you only account for inequality, you really want to redistribute a lot more, and actually you want negative taxes, so average positive transfers for the bottom 30%. If you then also account for my rising living standards, you really come back to numbers which are much closer than what you had to 1950. And in fact, if I compare that to the status quo, so our calibrated 2010 economies, you actually are pretty close to the 2010 economy. Actually, you may want to redistribute a bit more than what is the status quo in 2010. So you see that you have a bigger R. And these 3 percentage points is not so small in terms of welfare, but it's like much more comparable than what you would get if you had inequality only. Okay, I'm going to show you 2 more graphs. So first of all, so where does this effect come from? So with the formula of Viscott and Sugiyama, we can decompose and really measure the effect coming from marginal utilities from the effect coming from income effects. And so if we only account for marginal utilities, that is the purple line, and you can see that we even overshoot actually. We go even lower than what the yellow line would tell you. So really the biggest part of the effect is definitely coming from this marginal utility story. The second thing I want to show you is the relative importance of like the overall fall in prices versus the change in relative prices. And so here, in the blue dashed line, I'm showing a counterfactual economy in which I generate the same amount of real income per capita, but keeping the prices constant. And what you can see is that, so you go to a number that is pretty close to my yellow line, meaning that the changes in relative prices are not super important quantitatively. Yet, of course, because the price of food fell by more than the price of services, when you account for that, you can redistribute even a bit less because the poor consume more of this of the food. So that's it. I'll close there by saying that. So overall, we find that accounting for like the patterns for consumption share across goods is important to determine the optimal level of redistribution. And so we really thought only about long-run things, but you could think more about also implication for the business cycle, which is something that we haven't looked at yet, but maybe we'll at some point. Thank you.
First of all, I want to thank the organizers for the conference, for having me as a discussant of this paper. I really appreciated reading it and studying it. I really enjoyed the paper. It is a very solid paper. It has a clear contribution, and it is also at a very advanced stage. So my comments will be quite modest in scope and will mainly concern some maybe refinements or clarifications. So the objective of the paper is to study how optimal redistribution changes in the US, following two important phenomena that occurred in the US since 1950, which are large increase in overall income inequality, but also a substantial increase in living standards. Through the lenses of a standard model in macro public finance, an increase in inequality would call for stronger optimal redistribution, but the same very model would predict no change in the tax and transfer system following an improvement in living standards. And the main reason for that is the assumption of homothetic preferences. So what the authors do in this paper is actually deviate from this assumption of homothetic preferences and re-examine the question on how these two phenomena shape the optimal redistribution in the context of non-homothetic preferences. One of the main quantitative results is the fact that the increase in optimal redistribution implied by rising inequality is somehow mitigated once you take into account these non-homothetic preferences and the rise in living standards. So the paper is organized in two parts. The first part is a theoretical one, and it employs a merely setup which is augmented with non-homothetic preferences. And in this part, Axel and her co-authors study what are the implications for the equity efficiency trade-off of an increase in living standards. In the second part of the paper, there's a quantification exercise which employs a more IAGR style of model. Okay, so in the interest of time, I'm gonna go straight to the discussion. The first point that I have regards the assumption of non-homothetic preferences, which is the main novel innovation of this paper. They are very very widespreadly used in the structural transformation and development literature to capture the idea of basic needs. So a first question that I have for the author is, when comparing the US economy in 1950 and the US economy in 2010, so two economies that are very far apart of time, very, very different, have these basic needs changed or have they remained stable over time? And relatedly, how do these common style non-homothetic preferences account for or accommodate the idea that what is a luxury today could become a necessity tomorrow? So I'm explicitly thinking about, for example, healthcare services, education, and housing. Second point regards more the quantification exercise, in particular on the empirical evidence that you use to calibrate the model, and in particular the change in living standards. I think you use mostly macro data on the change in prices and the increase in mean income. There's also some micro evidence by Heathcote, Perrin, Violante in this paper in 2010, which shows that obviously there was a big increase in the living standards in the US, but this concerned mostly the top of the earnings distribution, while for a large fraction of the period that you study, but not all of it actually, since 1967, there was actually a worsening of the living conditions of the bottom 5% or maybe 10% in most of the periods. So the question is actually your calibration consistent with this? Maybe it is. It's not clear to me. Anyways, this doesn't take anything away from the fact that it is maybe extremely important, even in this case, to account for non-homogeneities, to quantify what is the optimal degree of redistribution. Third point is about the fact that the quantification exercise is carried out in a partial equilibrium, so the changing prices are all fed into the model, and the rising living standards and the rise in inequality are treated as two exogenous and independent effects and trends. Somehow, I think this paper is actually about a big change in the US economy, and these two phenomena are part of a bigger story. So somehow it would be interesting, maybe not for this paper, for the next one, to have a unifying theory where both the rising inequality and the rising living standards are endogenously determined. I think a natural framework for studying this would be one with a skill-biased technical change, where inequality, the wage premium is endogenously determined, but growth as well, okay? The benefit of this framework would be that maybe, potentially, the tax and transfer system may have an effect also on growth, maybe it doesn't have. And the last point that I have regards the way the rise in inequality is examined in the paper. Somehow, you know that there's a very large literature on the topic. There are many interesting stories. It's so vast, the literature, that it doesn't even fit my slide. And somehow, the type of inequality that is accounted for in the paper is a specific type, right? An increase in earnings inequality. Obviously, it is not possible to encompass all of these sources in one quantification exercise, but I think that for the type of exercise, the type of question that the authors ask, there are two stories that could be extremely interesting. The one is the one related to falling tax progressivity as a source of increasing inequality. And the second one is the one on job polarization, so this phenomenon that there was a hollowing out of the middle class, so there was a shift in the mass of people in the middle class towards the bottom as a result of technical change, which would be important once you take into account non-homogeneities. That's it. Thank you so much. Thank you.
So, if I understood it right, if inequality doesn't change, and you only have this growth and non-homogeneity, you would have lower taxes and lower redistribution, right? So this implication sort of feels awkward when I think of cross-country kind of evidence, where normally I think of richer countries having more redistribution, bigger social state. And maybe it's not easy to think of what, when we do cross-country, many things have changed. But broadly, the question is, rather than comparing US over time, if you compare countries, poor countries and rich countries, to what extent do we understand what the differences across countries in terms of their redistribution and through the lens of your model?
Yeah, love the paper. I thought it was great, and I think the emphasis on rising inequality, but also rising living standards is a great one. On the endogenous growth comment, I don't know if you've thought about it, but would the non-homotheticity of the preferences be affecting that as well? So what would you get out of growth? I don't know if you've thought about it, but it does seem like over this kind of timeline, you'd want to think about. I mean, the public debate is really, should we redistribute, or would that hurt capital formation and hurt growth? That's really the public debate. So I think if you can get to that in a next version of the paper, I think that'd be great.
So I also liked very much the work. The only thing that strikes me a little bit is, given that you really take into account that the marginal utility changes dramatically, then maybe the Pareto weights are taken a little, is a theoretical exercise, but in terms of giving suggestion or speaking to the actual debate, maybe having these fixed Pareto weights is a bit, for example, if the welfare function were a concave function, maybe, of course, these Pareto weights are endogenous, but not only that, in general, would be nice to have some consistent way of saying what are these Pareto weights coming from, some political economy, whatever, that allows you to really speak to something that changes dramatically marginal utility, and because now keeping them fixed, is more a theoretical exercise than perhaps policy debate, in my view at least.
I think this is related to a previous question, but I was thinking about, there's also an issue about income mobility and how taxation impacts on mobility across the distribution.
So thanks for all the questions. Let me think of in which order I want to answer these questions. Maybe let me first answer Anmol. I'm going to start with you about cross-country evidence. So here, of course, there's a question about fiscal capacity, right? The capacity of raising taxes. But we did have at some point a calibration with China, and we are doing cross-country. We dropped it for now, but it's something we looked into. Like, then it would mean different distribution of Pareto weights. You can always generalize it. But this notion of fiscal capacity, we didn't have much to say about, so we stopped there. So about partial equilibrium, so I very much like your idea about having so exogenous growth, but generating both the rising in living standards and the rising inequality. And in fact, we had a version where we had that with like skill biotechnological change, because we thought that maybe then taxation is going to affect relative prices, which then are endogenous, and that could be a new motive for redistribution. Okay, that was quantitatively so super microscopic tiny that we stopped. And endogenous growth would be, of course, the next step, but we haven't thought about it yet, but it's something we have in mind. Then about, so the comment about like inequality in 1950 versus now. So we are now working with CX data from the other way from 1960, in which we were trying to compare actually how poor are the poor in 1960 to 2010 in real terms. So you do see a delta in our model. So in 2010, everybody is richer, but as you said, there's more variance, so the poor are also poor. So how we compare this to the data, we have to check it. It's important. Okay, so keeping the Pareto weight the same. So yes, it's a strong stand. In favor of it, I would say that then the optimal 2010 is not so far from the real world. So if you think the government is optimal, maybe that's a way to confirm that the Pareto weights is a good assumption. Of course, it's a bit of a stretch. We did try alternative things like fixing weights by percentile. We did try a little bit with that. That's something we could do in a more systematic way. Of course, it's going to matter because it's a quantitative exercise, so if you change your Pareto weights, it's going to change. But yeah, I think it's a natural benchmark to take one stand on Pareto weights and then not changing them anymore, but of course, it's a strong assumption. External habits, so that is something we have thought about as well. Sort of like for now, we are matching the heterogeneity in IES. So I could think of external habits. The question is how we would alter these intertemporal properties. And I guess there are different ways of writing it. So yeah, we have to explore that more, but it's something that clearly we are not doing for now. I also had your comments on like, oh yes, goods, I mean, different type of goods may have changed over time. So this, so Comin et al., so in their paper, they spend quite a lot of time arguing that these elasticities are actually stable across countries, across relatively long period of times and in the cross-section. Of course, it depends on the definition of goods. If I were to go to very, very small, very narrow definition, say a phone, that wouldn't be true anymore. But at this sort of broad categorization, it's sort of fine. But yeah, again, it depends on how you want to call, I mean, how you want to define your goods. And I forgot Morten's question, sorry, I didn't write it. No, was? Inco, okay, yes, okay, so I talked a bit about that already. Okay, all right, thank you.
We have a coffee break right now.
I didn't fully get the answer. So,
What will be a 20-minute break?
It's registered, so it's on. It's like this is okay.
Welcome back, and please have a seat so we can get started. Here we go. Yeah.
New norms.
New norm. New session, new norm. So everybody's with me because I don't want to feel alone as Pietro. That's why. So, okay, thank you very much for being here, all of you. And this is our second session of the workshop. It's on fiscal policy and its transmission mechanism. And we are very fortunate to have two distinguished speakers with us, Sara Zubairi, whose research has advanced our understanding in how government spending affects the economy, and Domenico, who is a leading scholar on business cycle fluctuations and risks. So they are going to have two papers, like examine fiscal policies on different dimensions, and I think you will enjoy a lot this session. So please, Sara, go ahead.
So thank you so much to the organizers for inviting me to present a paper here. This is joint work with Gumbi Park, who's a grad student at A&M, and Xiaoqing Zhu, who's at Dallas Fed. So the usual disclaimers apply. So you mentioned fiscal multipliers. This paper is also about fiscal multipliers. And in this literature, defense spending has been used a great deal because it's very attractive for identification purposes, because usually it's because of geopolitical tensions that defense spending goes up, and then it's broadly exploited as a source of fiscal variation. And then in particular, federal prime contracts have been used as a source of cross-sectional fiscal variations, and so defense prime contracts have been used at different aggregation level in the context of the US at county level, state level, to estimate local multipliers. And then those can be used to understand transmission mechanisms, explore heterogeneity, and then you can also get some implications for aggregate multipliers as well. But one simplifying assumption that is common throughout this very large, actually, literature is that the place of performance of the defense prime contract is assumed to be the place of impact when we're thinking about local multipliers. And the seminal paper that introduced a lot of these methodologies, Nakamura and Steinson, also raised the issue that one potential issue could be that an important concern could be they were looking at state level multiplier, an important concern could be the extent of interstate subcontracting, so that, you know, dollars are coming into a state for prime contracts, but then they might be subcontracted away. So in this paper, this is, to our knowledge, the first systematic empirical analysis of subcontracting for defense prime contracts, and we're going to document some facts and then think about the implications for the transmission of government spending. So what does subcontracting look like? So the Department of Defense is handing out these large prime contracts. So in this particular example, this is a specific contract that they handed out for $88 million for aircraft components to Boeing Company, where this is the place of performance of this Boeing is in St. Louis, Missouri. But then they further subcontracted it out to different firms. So there are the names out there, but one thing I want you to notice is that the money didn't stay in St. Louis, Missouri. It's being subcontracted out to states on the West Coast, so, you know, in California, to Washington, and to other states, Arizona, Pennsylvania, Alabama. So for subcontractors, there is like in the data that we have coming from the usaspending.gov, there is a column that gives us a brief description of the nature of these subcontracts. And so the amount of information is discretionary. So some have very large details, some have just you know, little segments of sentences. So the descriptors are about that they're doing different like avionics or aircraft support. They're not super specific, but they give us an idea that these are subcontracts which are for products and services that are needed to complete the job that the prime contractor has been contracted to do. And so in this particular case, out of this 88 million, about 25% of the funds are going towards subcontracts. This subcontracting reporting became broadly mandated by the Federal Funding Accountability and Transparency Act in 2011. And so part of the reason why this earlier literature, Nakamura and Steinson and a lot of the follow-up literature did not, you know, did not delve into the subcontracts is also data availability. So now we have data, and so we're going to be exploring it. What kind of magnitudes am I talking about? So on the left side is the prime contracts as a share of GDP. These have been studied a great deal. Maybe some of you have worked with them as well. So if you look at it, it's about 2% of GDP, the prime contracts, the DoD prime contracts. And, you know, there is variation over time. There's the build-up post 9/11, and then there's the drawdown after the Budget Control Act of 2011, and then there was pick up again around 2019 after the end of sequestration, and then, you know, hostilities and related to in the South China Sea, and also DoD priorities, where they wanted to focus more on shipbuilding and aircrafts. And so, you know, there's that variation in the prime contract share. And then on the right side is the subcontract share of prime contracts. So on the right axis, you can see that it has gradually increased, and, you know, around 2018, it was about 20%. And then that big increase that we see in the total prime contracts, a lot of it also shows up in the surge or a big increase in subcontracting spending as well, which is, you know, related to this defense buildup, DoD priorities, and policy intentions. So, you know, at the peak, it's about 55% of prime obligations are going towards subcontracts. when we look at how it's distributed, a lot of it, that increase, yes, the number of subcontractors have been increasing over time, but that specific buildup is driven a lot by value of subcontracts. So there were some really large subcontracts there. So a lot of variation in the intensive margin during that time period. But overall, we see there's an increasing pattern. So what is the paper trying to accomplish? So the question we're addressing is, to what extent does subcontracting reallocate federal spending across geography? I gave you a sense of that that's happening across industries and across firms. And then to get at, like, why should we care? Well, does it matter for the change in the transmission of government spending shocks? So our broad approach is that we're going to be linking these DoD contracts, which have information about the primes and the subcontracts, with establishment level data from the NETS's National Establishment Time Series. And then we're going to the first part of the paper, I'll just show you lots of pretty pictures. These are just stylized facts about the subcontracting reallocation. And then using those facts, we will revisit local fiscal multipliers. And then since we have firm level information as well, we're going to examine firm level responses to primes and subcontracts. So the main headline results are that when we account for subcontracting, we find that the overall conventional measures of prime contract multipliers, which only focus on the place of performance of the primes, we find there is a bias there. We find estimates that are 10 to 20% larger, but they're not, like, statistically significant. So overall, the conventional multipliers are not materially affected. But one contribution that was not there before is that we also estimate multipliers for these subcontracts. What is their impact on the local economy? And so subcontract multipliers are estimated to be much smaller than prime contract multipliers. And so the broad implication is that the rise in subcontracting is expected to weaken the transmission of spending. Yes. So in this paper, we are focusing exclusively on domestic. So most of these, even primes go abroad as well. So this literature has focused exclusively on defense contracts within the US, and so we've also been looking at subcontractors within the US. But now, right now, actually, we've been looking at, we are exploring primes and subcontracts going abroad. And the subcontracts going abroad are mostly initiated by domestic primes. So to your question, yes, there are, but they're not in this paper because we wanted to focus more on the local multipliers. It's a small share. So for primes, at least, it's like 3-4% go abroad. I don't have the percent of how much of the subcontracts go abroad. Okay, so let's get into the stylized facts. So there is a great deal of spending reallocation through subcontracts. So first is geographic reallocation. So this is in 2019. I'm showing you a figure at county level disaggregation for prime contracts. So the darker blues are where we have a higher intensity of prime awards going. So 2019 has about, in 2019, about 40% of the prime contracts were awarded as subcontracts as well. So this is where you can see, first of all, this is why we've used local variation in prime contracts, because there's a lot of variation, right? So then, not all prime contracts lead to subcontracts. These are sub-award outflows. So these are counties from which the primes lead to subcontracts. So then there are fewer of them, a lot more on the coasts. And then, so these are where the subcontracts are originating, but where are the subcontracts going? They're also pretty dispersed. Like, they're also going all over the country, and areas in the middle of the country also light up. So the reds are high intensity, high exposure regions. So this is just to show you like how there is massive geographic reallocation happening. If we look at the performance location, 71% of it based on value is happening in different states, and 90% of it is happening in different counties. So that was about geographic reallocation. Second fact that we're going to be looking at is cross-industry reallocations. So what do primes and subcontracts deliver? So within the database, we have, for the primes, we have very neat information about product service codes. So that helps us identify what exactly those primes are related to. And then for the subcontracts, we don't have that exact information. We had to do a lot more work given those product descriptions and the names of the firms to kind of help us figure out where they're headed. But this is basically the figure we come up with. So you can see on the left side is where the prime contracts originate. So as one would expect, most of the prime contracts are coming from weapons, R&D, specialized equipment, aircraft, ships, land vehicles. Those are the major areas where the primes are originating. And then if we look at the subcontract side, you can see there is a lot of, a lot of dispersion across different industries. So a lot of these are heading towards computers and electronics, and that's also understandable. You know, we are looking at the data sample from 2011 until 2024. This is the period where our defense industry is also modernizing, and computers and electronics are components in every single thing. There's professional equipment and services. So those are the larger areas where we are, where the subcontracts are heading. And a lot of them are more product-based, and they're coming from broad industries. If we try to summarize this, the thing we took away was, again, to our maybe our surprise a little bit, is that subcontracting shifts spending a lot towards goods production. In this column, we have each row, the value is showing, each entry is showing the value accounted for by subcontractors in a given industry coming from a particular prime contractor. So the diagonal is showing us when, you know, so for instance, manufacturing, a lot of the primes in manufacturing, the subcontractors, 80% of them are also in the manufacturing industry. But then for some other sectors, there is a lot of reallocation where for trade and services, we see that, 65% for trade are going towards goods producing sectors, and some other services too, 35% of them are going towards goods. So, high valued services industry are information, finance, profession, business and technical services. Even there, 22% of them are going towards good producing sectors. Now, why do we care? Because we know that labor intensity might differ across goods production versus services production, and that will be part of the story that we'll be telling later. So, you might be doing R&D, but then you need the computer components and so forth. Okay, and then the next fact is about the size of the firm. So the beauty of connecting this DoD contracts to that establishment level data is that then we know something more about these particular firms than what is readily available in usaspending.gov. And one of the things we know there is the number of employees in a given firm. And so here again, like if we look at the size of the prime contractor and the match with the subcontractor firm, we see that a lot of prime contract dollars are going to subcontractors which are large, and large here are just defined as ones having more than 50 employees. So even small prime contractors are contracting to 58% subcontractors which have greater than 50 employees. So there is a shift towards larger firms. So what these facts are showing us is there's widespread geographic reallocation and subcontracting shifts spending towards large manufacturing firms. Now, why does this matter? First of all, we're going to be revisiting the local multipliers, and we're going to be looking at whether this biases our understanding of the local multipliers, what are the effects of subcontracting, and if there is a difference, how can we explain it? And so there we're going to be using, first we're going to be looking at county level evidence, which is what geographic variation is what's used in the local multiplier literature, so we're going to be following that lead. And then in the next part of the paper, then we look at firm level characteristics to look at the direct effects of those prime and subcontract dollars. Okay, so first let's go to local fiscal multipliers. This is a big literature. We're just going to take the broad approach that's been taken in this literature, and we just want to illustrate how do we think about subcontracting in this particular framework. So this is the basic framework that's used to understand local fiscal multipliers. So on the left side, the Y variable is some local economic outcome. It could be earnings, employment for a given. In this case, we're looking at county level data. And then we're doing a local projection so we can get a multiplier at different horizon interpretation. And then on the right side, you have the GI, so government spending going to that particular region. And then the conventional approach was where's the defense spending going to a particular region based on the place of performance of the total prime contracts. And then there are county and time fixed effects in those equations. Okay, so our approach is we're just going to be taking that equation and modifying it. First of all, we're going to be correcting the measure of primes. What we're going to do is we're going to we care about retained prime expenditures. So this is total primes going to a particular location and then accounting for the outflow of subcontracts from a given county. So that's going to be our measure of adjusted prime spending. And then separately, we're also going to account for all of the inflows of subcontracts from other counties into that particular county. And then we're going to consider those multipliers differently, separately, so that the beta k is going to give us the local fiscal multiplier for the prime spending, which is just a corrected version of the local fiscal multiplier that the literature has looked at before. And then gamma k is going to give us the subcontract multiplier, which is the new thing that we are considering now that we have this information about subcontracts. So in this literature, we do care about the source. We do care about endogeneity, that, because of some political affiliations or, primes might be going into a certain area. So the common approach is to use IVs, and the IVs are typically shift share instruments. And there, the identification is driven by the fact, here we're going to be relying on three things. One is what's standard in the literature, that we are looking at the movements in the aggregate amount of primes, and that's driven by, geopolitical tensions and other factors which are not related to the local economic situation in a given county. And then the second part of it, we'll have a same type of shift share instrument for subcontracts. And again, changes in the subcontract amounts at the aggregate level is also going to be driven either by our defense needs, DoD priorities. There are federal requirements that large prime contracts need to have some level of subcontracting. So it's driven by those sorts of concerns, again, not related to local economic conditions. And then the share part is we take a predetermined share of those prime and subcontracts. And so we're going to be using these shift share instruments to estimate these multipliers. Okay, so here are the multipliers. So this is for employment. So we're looking at county level employment. So when there is a 1% increase in local earnings, when there's an increase in primes, which is 1% of local earnings, this is the impact on employment. It goes up by 0.2, 0.3%. This is, these estimates are consistent with others who have estimated county level local multipliers for similar samples. So the black line is what the conventional approach would give us. Our approach with the correcting for outflows gives you the blue line. So the point estimates are higher, so that this correction of accounting for outflows of subcontracts leads to this upward movement in the corrected primes. But then they're not statistically different. But then these are the subcontract multipliers, which are significantly lower. So subcontract effects are much lower than prime contract effects, and we find similar patterns for earnings. One of the reasons people care about the employment multipliers is that then you can give it more economic meaning in terms of cost per job per year. So if we take that, and let me just illustrate why this would matter. I'm showing you Los Angeles County, California, which gets a lot of prime contracts. So in this figure, if I use my average estimates of the cost per job per year based on those employment multipliers, if we take, so you can see that the blue line is showing you the variation in the prime contracts over time. And then the red line is showing you that even in Los Angeles, there was a large increase in subcontracting post-2019. And so there was this difference in what types of funds were flowing in. If we account for the multipliers being the same, if we if we account for this difference in the prime and subcontract multipliers, the black line is the implied implications for jobs per year in thousands of dollars created through defense contracts. And it would be very different if we assumed that those dollars had the same multipliers, which they don't. It would be much, much larger. Okay, so why do subcontractor contracts have weaker effects? First, so these are local multipliers. So one way we can get at it is let's focus just on the direct effects. Let's look at the firms that actually receive these prime contracts and the subcontracts. What is their effect on employment? And so there we have this firm level panel data. And when we match it, we were actually very pleasantly surprised that 91% of DoD contractors, prime, and then also the subcontractors, can be matched. But this data set, it needs to be clean so that it looks more like the census data. So once we put in those restrictions, 44% of the firms are matched. And then we are just going to be we're going to be doing sort of an event study exercise where we're going to be looking at, again, Y is going to be a firm level outcome variable. So we have information on firm level employment, firm level sales in this particular data set. And we're going to be looking at what would be the impact of receiving a prime or receiving a subcontract. And then we have firm fixed effects and industry time fixed effects as well. So the results I'll show you will be for the indicator. So if you receive a prime, what's the effect on jobs created, on employment? But then we also do it with dollar amounts as well. So these are the average effects. So we are looking at the blue lines are the prime contract effects on employment. So you can see they're much larger than the subcontract effects, which are the red lines. So whatever we found at the county level for local multipliers, we can sort of corroborate that at the firm level, the firms themselves that are receiving these contracts, there is a smaller rise in employment of the subcontract firms than prime contracts firms. And this is robust if you account for amounts in terms of dollars as well. Same pattern for sales. Then why do these subcontracts have weaker effects? We delve into whatever information we have about the firms, which is not a lot, but we look at, we distinguish between small versus large establishments. So again, the definition is larger or smaller than having more or less than 50 employees. And what we find is that large firms, whether it's prime contracts or subcontracts, they have a weaker employment response. Small firms tend to be more responsive in terms of employment when they receive a prime contract and also when they receive a subcontract. Then we also divide the firms based on whether they're in the goods industry versus services industry, and we find that manufacturing firms have a weaker employment response, again, for both prime and subcontracts. So the composition seems to matter. When we look at the decomposition to see like the total difference, how much of it can be explained by if we were just focusing on small services firms, if we gave the same share to subcontracts, how much would it explain? It explains 30 to 40%, so we need another explanation. And the other one that we provide is that subcontracts tend to be less stable than prime contracts. So here we're just, if you had a prime contract in the last period, so we find that prime contract relationships are more persistent than subcontracts, and if you are given for a subcontract, if you have a relationship with a prime contractor, it's more stable for smaller subcontractors than for larger. So that sets up expected demand, right, when you're making decisions about hiring or not. Okay, so I'm basically out of time. I just want to say one word that, at the end of the day, we care about aggregate multipliers. So we do have a model in the paper of simple framework where we have these mechanisms about composition and contract frictions to differentiate between subcontracts and prime contracts. And the main takeaway is that the subcontracting mechanism does not wash away in the aggregate. It matters for the aggregate multiplier as well because it changes who produces, not just where the dollar is going, because we see that the subcontract dollar has different employment effects. We thought we were exploring an interesting data set, but now, living in this fiscal policy in an era of uncertainty, the US government is again talking about defense procurement, the processes, and so subcontracting plays a very important role in this defense industrial base and its economic impact. So then, you don't like the news, but in some sense you find a relevance of what you're working in the news, and that's always exciting. Thank you.
Now we have this 10-minute discussion and then a Q&A session.
Okay, thank you very much. Thanks to the organizers for inviting me to discuss this paper. Somehow I managed to erase the disclaimer, but so I say it. I work at the IMF, and this has nothing to do with the views of the IMF. It's just me or the board or anybody. It's just my views. So thank you. I learned a lot, so I really like the paper a lot. There's a lot of work that Sarah was humble enough not to describe on just how to match data of firms. So really the contribution to the literature and to the further work of others is really very large. So I'll break into two parts. First, just going over what they do and how I see the paper, and then a couple of suggestions. The paper is also very mature and maturing more. The first version I downloaded, there was no model. Now there is a model. So it just keeps getting better and better. So it was tricky, but I'll try. So what they say, and Sarah explained this very well, is typically the literature would look at prime award location when trying to estimate a multiplier at a county, and then kind of jump to perhaps firms, earnings, and that's it. So that's the final geography of federal demand that the literature was doing. So they say, well, there are steps in the middle, so let's try to fill them up. Does that matter? What they think is, of course, the macro object, if you are interested in a multiplier, is where demand is produced, not where it is awarded. So that's the question. So when federal procurement is subcontracted, how do geography, producer type, relation persistence affect employment and the multiplier itself? The answers they find is that subcontracting reallocates demand across counties, across states, perhaps across countries, as Jim was saying. That's not what they are doing yet. Sectors and firm types. Retained prime spending has a larger local employment and earnings effect than subcontract inflows. Not too different from what the literature was finding. So that's first part in terms of the multiplier, but yes, in terms of employment. And the gap reflects, so they do a lot of work as well in trying to explain why what they find, they are finding. So I like that as well. It's not only the empirical paper that says this is a multiplier, but they work a lot in trying to understand really what's driving this. So the contributions is, as I was saying, definitely the data, innovative data, lots of work going there. Then measurement, so you separate once you have this data. Matching with firm level data, that's a tremendous extra work to explain the gap. And then there is a model that tries to rationalize what's behind all of this. And it's also whether this could wash away once you have general equilibrium effects. So this, I think, Sarah explained well, but let me just very quickly go over it. So basically they have, in the classical literature, you have a prime origin, so that's the upper left blue line. And then this will be broken into subcontracts, so this will go somewhere else. So the contract will be awarded in St. Louis, but maybe it's produced in California because it needs chips or something like that. That's the retained part is what remains in St. Louis, subcontract is what will go to California. So the key work of this paper, one of the parts is the data distinguishes three objects that typically people kind of mix or take as one, which is the award location, the performance location, and the recipient establishment. So that's very big. And you know, they do a nice job with examples in showing, well, this actually matters. Because when you look at subcontracting, 94% of dollars cross-country lines, state lines as well, census region lines. So this money is really flowing across different parts. And that's going to have also a flow across sectors. Manufacturing receives more subcontracting, goods as well, and firm size. So large firms receive a lot of these subcontract obligations. To an extent, one wouldn't be so surprised, you know, if you're commissioning parts of a missile, it's going to be hard for my company to do it. I don't have any company, but big companies. Now, how do they go about doing this work? It's difficult. Of course, there is still identification issues, but they follow the literature as there is a shift share instrument, so a Bartik instrument, and basically they exploit two parts. So what is the shift? What is the share? The shift are the changes in national prime contract spending or in national subcontracting spending, while the shares are the given initial exposures to the different type of contracts, taking them over time and exploiting the identification. Sarah said perhaps at the county level, the government is not thinking so much when engaging in a war to fix St. Louis or something like this, or California. Here are the results. So the first part is, well, the multiplier. You do all of this work. The multiplier itself is not that different, so that's a heuristic version of what Sarah was showing on multipliers. But what is true is that the subcontract, the new object, the black line in here, that just didn't exist. The multiplier for that is lower, much lower than the others. Thank you. So it's good that I'm right in the middle. What is more brutal in some sense, and the paper makes a big deal out of this, is that the employment effects are very different. So when you look at the employment effect of spending on military, and especially in the paper they also try to compute, and Sarah used it later, what is the cost of creating a job when you're doing you know, the primary contracting, so when you say this goes to St. Louis and the production is done in St. Louis, versus when you are actually subcontracting and you need to spend much more to generate a job when you take into account this subcontracting. So that's, I think, some of the main parts of the paper. Why the gap appears, I'm out of time for this first part, but the paper moves from the reduced multiplier to who produces, how persistent the relations is, especially in terms of employment. So the point is they say, well, you know, if you're a prime contractor, you know that you're going to count typically with a contract of the government, so you feel confident of hiring someone to produce this, because on average you get a certain number of contracts. They find and document that with the subcontracts that is much more volatile, so the probability of a firm willing to engage in hiring someone for a year is lower. So that's an important part of the transmission mechanism that I think Sarah had to rush. And there is a model, too complicated here, But just a picture, I don't want to say too much more about it, but it's really pretty nice because it says, well, okay, let's take seriously the input-output matrix across regions. Firms are going to choose labor, capital. Then there are frictions, like what I described. You know, there's going to be some firms may want to hire or not hire, depending on the volatility. And then there is general equilibrium where everything moves around. And they say one of the problems could be, in general equilibrium, will this disappear? No. Can I justify all of the mechanisms we find typically in the empirics? Yes. So I think that was lovely in the sense that it all works very nice. And it's a very, very sophisticated input-output matrix. I didn't see that before. But you could even make it more sophisticated. Since I didn't see the model, I started with something a bit more inter-region, because maybe you say, okay, the contract goes to St. Louis, which in turn goes to eventually to California, but maybe the guy in California has the sons in St. Louis and it goes back to Clayton. So the input-output linkages can be much more complicated than what they have, and I'll explore that in a moment. So now I go into my comments and a couple of things. So the paper has done already a lot in trying to understand, but there could be a little bit more that they could do. So people work on these shift share instruments, what people call the Rothenberg weights. There is a paper by Goldsmith and co-authors in AER of 2020. And you basically can try to detect a finer, you can get a finer understanding of what's giving you the identification. So right now you go at the higher level, just county or subcontracts. But then you can go instrument by instrument, or what sector is giving you the identification. Is it the big firm of missiles that's driving everything, or is it really widespread? So, and there are ways very explicit to do it. I think it will be nice to answer the question of whether your identification and the values of your multipliers and coefficients are coming from everywhere, or is just a couple of sectors or a couple of firms, and we don't know, and it will be nice to see that. I'm going to skip this, pre-trained inference. I'm sure you have thought about that. Perhaps when I read the paper, I was reading, employment is lower, cost of generating employment, etc. It invited me, the paper doesn't say it, but it invited me to think, this is bad perhaps, or they shouldn't be doing subcontracting. That was crossing my head. But I think one has to be, perhaps the paper can be more upfront of what they want to do with those findings. Because in some sense, I don't think the objective of defense spending is to hire people. There could be other objectives. And maybe you could say, well, this is just the optimal way of producing at the lowest possible cost. And we should be very happy that they are outsourcing and doing whatever they want to obtain the mission target at the lowest possible cost. So to me, there could be more exploration of but this is not one-sided. So it could be that they are doing the best that they can to minimize cost, but it could also be that they are in turn monopolies, that they are exploiting other firms, and then you also end up with welfare losses. So this shouldn't go one way only, and that's why I think could be worth exploring it more. Perhaps it's a different paper, but I don't know what to do with the labor effects in general if I were thinking more welfare. I was saying, so I was very excited, so I did a much more complicated model. So I just complicated more the graph, but just 2 points, because I started with that. So I had a much more complicated matrix there, more endogeneity on the costs, but this is a discussion that went nowhere because I simulated everything, and what I found is that the results of SARA were very robust. So I was worried in my head that the money could flow in much more complicated ways when you take general equilibrium effects. And what they find, and I'm out of time, is just that, no, the results are pretty robust. I even calibrated them on simulated, but didn't get anywhere but to say the model is more robust and your results are more robust than you even think. So, so I close here. Thank you very much. Thank you.
Okay, let's take some questions.
Thanks. Very nice paper and really relevant for the discussion in Europe at this juncture on defense spending. So maybe 2 questions, and I think a follow-up from what Andreas was talking about. So first, should we think about subcontracting as a leakage or an equilibrium response to, say, capacity constraints? I mean, you have low bottlenecks, so the prime decides to subcontract. How should I think about that? That was not clear to me. And the second related question is that could subcontracting intensity be counter-cyclical or pro-cyclical depending upon the extent of local labor market slack? Right? So if depending upon the extent of local labor market slack. So if, the first part was capacity constraints more generally. The second one was, if you have, is it pro-cyclical or counter-cyclical depending upon local labor market conditions, right? So think about, if labor is tight locally, the prime subcontracts more, or when the uncertainty is high, they want more flexible capacity. So your multiplier could be smaller because it's capturing some kind of a state dependence in make versus buy decisions than anything else. So how should I think about this?
Very quickly. I was recently in a meeting with the generals of Italian army. It was between academics and generals of the Italian army, and we asked them the question, what do you think are the main problems in measuring the monetary multiplier? And there was a very interesting answer. And we said, the guy said, look, when the government gives out a contract to produce ammunition, the price of ammunition goes through the roof. I think this is relevant.
So two very quick questions. The first one is whether you looked at all at when you try to understand what explains the lower multiplier for the subcontracts. So whether you looked at the size of the contract per se and the length of the contract. And the second one is more, it seems to me that the sum of the subcontract and prime contract multiplier is higher than the general prime multiplier. And so I was wondering what friction might explain that difference between the two and whether that difference was significant at all. The difference between the sum of your two multipliers that you measure and the general multiplier that you would have from just using the prime contracts. Because I was thinking in the end, the general sum of money dispersed by the government is the sum of prime contracts, right? And so the subcontracts are just money going from the prime contractors to the others. Yeah.
Let's take two more questions. And then
Thank you. So I have a question for Carlo. Carlo asked generals about the size of multipliers. I'm impressed that is. My question to the paper. So in Europe, the discussion about procurement for the increase in defense spending is also a lot about where does the positive growth effect go? And so is that also true for US procurement? And then is that subcontracting just a way of the system sort of creating efficiency, even though the initial procurement allocation across space is largely politically determined, right? And that goes a little bit to Ara's question about whether this is a good thing or a bad thing.
let's take the last question and then we give the floor to Sarah.
Very nice paper. So I guess I have a question about next steps in the literature. It seems like it should be unexpected allocation of a contract, not an expected one. And so I'm wondering how the literature handles that. If you think of the St. Louis Boeing example, they built F-15 fighter jets in St. Louis for decades. So they're expecting maybe a little bit of waxing and waning in how many fighter jets are going to be ordered, but basically the capital and the labor is just sitting there waiting to build the next fighter jet. And so a lot of the talk in town was just, whether would it be, 57 fighter jets or 43 fighter jets or something like that. So you'd want the unexpected component would be what would drive any employment effect. So I'm not quite sure if this is being handled in the literature or not. I couldn't get it from what was being said here.
Thank you very much, Sara. So let's move to the second paper of the session. So Domenico, please, the floor is yours. Fiscal multipliers and economic risk.
Thanks a lot for putting this paper in the program. So this is joint with Francesco from University of Palermo and Davide from IMF and Gianni Trovato from University of Rome Tor Vergata. Davide works at the IMF, so here there are the disclaimers that these are not necessarily the opinion of the IMF. So what we do in this paper is study whether it's a classical question, very classic question about how effective is fiscal policy as a macro stabilization tool. And so there is a lot of literature on this. This is the literature on the fiscal multiplier. And almost all the literature has been focusing on the average effect, while here we are going to look at the effect on macroeconomic risk more generally. And so let me start with a refresher. I'm going to spend the next 5 minutes as refreshing how people have been studying the fiscal multiplier by looking at the average effect, and then I will build on this to see how we look at the entire distribution. So this, so as I said, this is the central question here is how effective is spending, fiscal spending in stimulating the economy. There is a large literature basically estimating the change in the output per dollar spent by the government. So if the government increases spending by $1, what is the effect on output? And as I said, almost all the literature focuses on the average effect. And here we are going to build on a paper by Sara and Remy, and which we are going to refer it as RZ from now on. I'm going to refer often to this paper. And so this slide is summarizing how Sara estimated this multiplier on, so here we have on the dependent variable is output, and the independent variable is spending. So we are interested in the effect of spending on output. Here, output is computed as GDP over its potential. Spending is government spending over potential. It's cumulated to look at the cumulative multipliers. And then we have also a bunch of controls, the lags of output, spending, and then the shocks. So, so data is this is secular data from the end of 1800 up to 2015, quarterly data, and so our multiplier is, so this model is linear, is going to be, I don't think it's pointing here, is going to beta h is our multiplier, is the multiplier at horizon h, where h is quarters. And this is the average effect, okay? These are the data. On the top you have output, then on the middle is government spending. So you see that there is a lot of variations in both output and spending. And on the third panel here, there is Z, which is an instrument we are going to use to estimate this multiplier. So these are defense news shocks. And so here the shades are the NBR recessions. You see that there is a lot of variation both in output and in spending. So we know that the spending is endogenous. You know, fiscal actions might react to the state of the economy, and so you have reverse causality. So plain regression is going to be biased. So an instrument is a way to assess the causal effect of spending, and you need an instrument that is relevant, so correlated with spending, and also exogenous and not related to the state of the business cycle. And so once you get this instrument, you can use IV to estimate these average effects.
And the instrument that was built by Remy is this defense news. So basically, it's the expected change in the military spending. And this is the expected change that is driven by political and military events rather than the business cycle. So that's why you can use it as an instrument. So these are unanticipated. So there is a large shift in expected spending. So the government spending. And then, they are also strong. You have a first, they explain a lot of variations of spending these instruments. And so this is a classic way to study the fiscal multipliers. And this is the effect that you estimate in this case. So here on the x-axis is quarters. So this is the beta h is the multiplier after h quarters. At 4 is 1 year, at 20 is 5 years. And so you see that the multiplier, the contemporaneous one, is above 1. And then as time goes by, after 1 year, it stabilizes at around 0.7. Okay, so for $100 of government spending exogenous, you have a $70 increase in output. Okay, and so this is basically all the literature on fiscal multipliers. Okay, so this is the kind of numbers we look at when we look at multipliers. And the important aspect here is that this is the average effect. Okay, so what we are going to do here is to look at the effect on the entire predictive distribution of output. If I increase spending today, what is going to be the effect on, let's say, upside risk or downside risk or uncertainty? Okay, so we go beyond the average effect. So we look at economic risk. Now, why we look at that is that in the last 15 years, we have understood that there is a significant variations on risks over the business cycle. So risk is changing a lot, and it's also predictable. And in addition to this, we know that there is a lot of variations, especially in uncertainty, which is counter-cyclical. When the economy performs bad, so when you have an average effect output going down, you also have an increase in uncertainty. So this is mainly based on predictive regressions, and there is very little causal analysis on this. And there has been some causal analysis looking at the effect of uncertainty over the business cycle. So in this case, people have been considering uncertainty as exogenous. Well, what we do here is to say, is it really exogenous, or is policy able to affect uncertainty? Okay, so this is what we are doing here. So the average effect is looking at how much does GDP change on average after a fiscal spending. And what we are going to look at, that's the classical way of looking at the problem. We build on this and also look at what is the effect on the variance of GDP, okay, on the uncertainty about economic activity. Okay, so this is going to be the risk. Okay, methodology, very quickly. As I said, we are going to build on the literature of the average effect. So we keep the estimate on the average exactly the same of SARA. And so we keep the same model in which GDP has the mean that depends on government spending plus an error, and the mean is a linear function of spending. Okay, so we have mu t plus h stands for the mean, so the expected value, which depends linearly on the spending. Okay, now what we do, we build on this, and here we have hat, meaning that we keep exactly the same estimates of SARA for the average. So what we do now, we look at the errors, and then we divide the errors in two parts. A part that is just the standardized error with W omega tilde, which has a mean 0 and variance 1. And then we have a scale effect, which is a sigma. And now this scale possibly depends also on government spending. Okay? And what we do is that the standard deviation of the shock is a linear function of the spending, as we did for the mean. So this is also known as a location scale. So when we look at the average effect, we just look at the shift in location. And while here we also look at shift in scale, which is basically the uncertainty. Okay? So the coefficient beta h up there measured the average effect, while here the coefficient, we have a new coefficient gamma h, which is attached to spending for the scale. This measures the uncertainty effect. Okay? We are going to estimate this. How to estimate it? So first, the mean equation is estimated, is kept basically the same as before, just a simple IV regression. And then the second stage, the new step here is that after we estimate the mean effect, then we take the residuals, we look at the absolute values of these residuals and regress now them on spending using IV to control for endogeneity, because you can also have endogeneity for the uncertainty. So for example, government spending might increase when there is an increase in risk for stabilization reasons. So and now if you estimate a gamma h, which is smaller than 0, it means that when you have an increase in spending, this implies a reduction in uncertainty. Okay, so here are the results. And indeed what we find is that this uncertainty effect is there, and it's significant. So we see that when there is an increase in spending, an exogenous increase in spending, you have this well-documented average effect, so going up the average, but also the uncertainty goes down. And this is the bottom panel here. So you have, the important thing is that what we uncover here is a simultaneous effect of fiscal spending on the average and on the uncertainty. Okay? So the average effect is boosting economic activity, and the uncertainty effect is reducing uncertainty on GDP. Okay? So what does this mean? So we can look at, so let's assume here that things are normal. So blue is before, think about the distribution of future GDP before you take a fiscal action. And then when you take a fiscal action, you move from the blue to the red. Okay? Let's look first at the density, okay, on my right side. And so you see what happens is that the average effect is that the whole distribution shifts upward, so the average goes up, but also the uncertainty goes down. Okay? So what you see then is that actually the tails, once you look at the tails, you have a very important effect here, is that the downside moves a lot. So here you see that the downside moves a lot because of this simultaneous shift, while the upside doesn't move much. Okay? And you can rewrite it in terms of the cumulative, so basically taking the integral of the density, and you can invert the cumulative, and then you get the quantile. The effect on the quantiles, which is basically is a way to look at, to measure risk, is by looking at the quantiles of this distribution. And you see that the effect from the blue to the red is on the left panel there, you can see a big shift in the lowest quantile and the very small changes in the upper quantile. So the lowest quantile is also called growth at risk. So it's a way to measure downside risk. Okay? While the upper quantile is measuring a sort of risk of overheating. Okay? So the simultaneous increase in the average effect and reduction in uncertainty means that you have a stronger effect on downside risk, mitigation of downside risk, and while you have smaller risks of overheating. Okay, so So this is summarizing this result. This chart is another way of looking at it. So the blue line is the effect on the average. So this is the average effect. The red is instead the effect on the downside. You see that the multiplier on the growth at risk is larger, while the green is the effect of the upside. You see that the overheating risk is instead smaller than the average effect. How significant are those differences? So here we are reporting these quantile multipliers for different quantiles. In every panel here on the x-axis are different quantiles. So once you do like a simple linear IV regression, you're basically saying all quantiles move in the same way, okay? And here I'm reporting, so this is the dotted line, and the shades are the confidence intervals estimated with this linear quantile regression. And then the straight line instead is the estimate that we get once we account for the effect of fiscal policy on uncertainty. And you see that it's significantly different from what you would get with the linear model. So this the fact that we get this increase, this decrease in uncertainty is not due to sampling, just to sampling uncertainty. It's a genuine feature in the data. So this is also connected, this result here is also connected with the literature on state-dependent multipliers. So basically, again, we are building on the paper by Sarah, who's looking at the multipliers in good and bad states. So an important thing is like this literature is looking at what are the multipliers different when you are in a recession rather than in expansion. Okay, and typically you tend to see that multipliers are larger during recessions. Now, there is an important aspect here is that fiscal actions not only have effect in different states. Like if you are in a recession, you might have a larger multiplier. Fiscal actions also affect on the probability of getting in the bad state. Okay, so if you know that the recession is coming, you might spend more and reduce the probability of getting into that recession. Okay, so our approach by looking at these quantile multipliers takes into account both of them. So here is a very simple algebra that shows that, for example, the average effect is the sum of these two effects. So here the prime means derivative with respect to the government. So it's the mu prime 1 is the multiplier during a recession, 0 during an expansion. And you see that the average effect here depends on the different effect on a recession and expansion, multiplied by their unconditional probabilities, times the effect on the probability, so the effect on the probability on the state. So, and by looking at the entire quantiles, we are taking into account both effects. So the effect on the sides and also the effect on the probability. And just to see how important it is, so this is another way to look at this effect on the risk. Instead of looking at quantiles, you can look directly at the probability for different thresholds. So here we are estimating a logit with where the log odd of GDP being below a certain threshold is a function of several things, several controls, including the fiscal spending. And we estimate this again with the IV and so on. And this is the result that we get is that fiscal spending is very effective in reducing the odd of a recession. Okay, so that's just another way of thinking about the quantiles. Okay? So instead of looking at the quantiles is nothing that the inverse CDF. Here we are looking just at the CDF. Okay? And of course, it also has, in a more complicated way, like the effect on probability and on the size of the multiplier in different states has also some effect on the variances that we are estimating here. So conclusions, as I said, we go beyond the average and look at the whole distribution, and we do it in a causal way. So we are looking at exogenous variation on spending, exploiting this, using the instrumental variable that is this defense news. So we have this, we find this new effect that of fiscal spending of uncertainty. So, and we find that the downside, the implication of this is that the downside multiplier is larger than the average, while the upside multiplier is smaller. So from this point of view, fiscal policy is a sort of provides as an insurance because it lowers the probability and the severity of bad outcomes with the limited risks on overheating. Something, just if I have one more minute, is that, so this effect, we have been working a lot on estimating this effect, the robustness of this new finding. Actually, it's extremely robust in the fact that, it's the effect on uncertainty of spending on uncertainty is a negative and significant. But of course, the magnitude changes a lot depending on the methodologies and so on. So here is one of the robustness results. I didn't put in the presentation because we did it before we shared our slides with the discussant. So this is basically, instead of using just a single instrument, we use two instruments as Sarah did, using also the Blanchard and Perotti instrument together with the news. And you see again, like the average effect is what has been estimated usually. It's in the upper panel. And you see that there is, this is the uncertainty effect. Okay, so you see the shape is different, the magnitude is different. However, this, the fact that it's a negative is pretty robust. And, so thanks a lot for your attention.
Let's move to the discussion. So Anna, please.
Perfect. So thanks so much for inviting me to discuss this very interesting paper. Great conference. And I guess it's really like the paper combining fiscal policy and uncertainty. So as Domenico said, of course, there's a long-standing question in macro whether fiscal policy is effective at stabilizing outputs. And there is an extensive literature on fiscal multipliers, but most of it focuses on a linear world. But we know well that our world is non-linear. We have huge uncertainty, high geopolitical fragmentation, swings in business cycles. So this paper looks again at this question, asking, is fiscal policy dependent on the level of economic activity and also its uncertainty? And this is the most novel part. And then, of course, if it is dependent, when it's more effective at stabilizing output and addressing macroeconomic instability. So the first thing that I want to point out is that this paper gives us a change in perspective about how we look at the question, because the existing literature really asks, let's start from a given state. So we condition on a given state. We are in a recession or in an expansion, for example. What's the effect of a government expenditure shock on the level of output? And popular methods that have been used are threshold VARs and state-dependent local projections. Many people in the room, like Sarah, Dimitri, Axel, have looked at this state dependence. And we know by now that government spending multipliers tend to be bigger in recessions at the ZLB. The size of the measure matters, the funding matters, and so on. All right, but this is conditioning on a given state. while Domenico's paper actually asks, what is the effect of government expenditure shock on the whole distribution of output, not just the current and future level? And they do so using like a novel method, at least applied to fiscal policy, which is making not only the mean of the outcome variable, which is output, but also the standard deviation being potentially affected by government spending. So the response of output, not only in its mean, but also in its variance, is endogenous. So the whole distribution is allowed to shift in response to the shock. And so this is super valuable because it allows us to look at multipliers at different quantiles of the distribution and see whether there is a difference. And so this is the picture that Domenico showed, but let me go over it again just to fix, to repeat the main results. So on the left we have the density function. The blue line is before the shock. Let's say we think of an increase in government expenditure, and the red line is after the shock. So we see that the whole distribution shifts to the right in response to a positive shock. So the mean shifts, but that we knew already from the literature on fiscal multipliers. So the main novelty is that we see that also the standard deviation changes. So the distribution shrinks. Like output becomes less volatile. And not only that, if we look at the plot in the middle, the cumulative density function, we see that the left tail shifts more to the right than the right tail. And this means that extreme events become less likely after an increase in government expenditure. And the third thing, like we can invert this density function and look at the quantile function. We see, and if we look at the distance between the blue line and the red line in the quantile function, and we look at the dots are the quantiles. So the dots to the left are the 5th quantile, and to the right is the 95th quantile. We see that the distance between the two 5th quantiles, pre-shock and post-shock, is bigger. So it means that government spending is more stimulative at the lower tail of the distribution. Okay, so these are like the main results using this new methodology. So now what I would like to comment on is a bit the concept of uncertainty that they use in the paper. So at the moment, the paper, at least the way I understood, is that is the dispersion in the output distribution. So it's mainly the standard deviation. But then there's a lot of discussion on upside, downside risk, which actually makes me think more of asymmetries and the skewness, so higher moments. So I was thinking like this model that is used, like this location scale model. At the moment, it seems that the mean and standard deviation are modeled as a function of G, but not the skewness. And then I checked the reference paper, Machado and Santos Silva, where they say that in this type of models, actually, the regressors affect all higher order moments through the scale function. So I was thinking, why not to model explicitly the skewness as a function of G as well? Or, thank you. Or it could also be that you are implicitly already doing this, because I was thinking, if we go back to the plot here, this is a normal distribution, so then the skewness should be 0, but maybe it's not, and then it means that you are actually already modeling it as non-normal, and then it's skewed. And so then maybe make it more explicit in the paper, because I think it's very interesting. It's probably the biggest contribution, just to have the whole distribution responding endogenously. And then again on uncertainty, of course, now you're thinking of uncertainty within the context of the distribution, but then there are other ways of measuring uncertainty, like macro uncertainty, economic policy uncertainty, just not specifically output, but capturing other aspects of the economy, financial uncertainty. So I was wondering, how is output dispersion affecting or correlated with these other measures of uncertainty? You could even run a regression where you have like other measures of uncertainty on the left-hand side and see how it squares with your results on dispersion. And then my other comment is concerning the mechanism behind this endogenous response of the distribution to fiscal policy. So the idea is that we have an increase in government expenditure, and then this reduces uncertainty, which boosts economic activity. So I have the feeling that the second arrow, like going from uncertainty to economic activity, is quite well understood and explored. We know that uncertainty creates a drag on the economy and has a negative impact, and here there are various channels like the real option theory, like firms wait and see before like investing because it's sometimes non-reversible. Firms, households have precautionary behavior, there's policy uncertainty. So this second arrow, I think we know. We know it's like more like understood. But I think what is novel, at least, I mean, less explored, is the first arrow, like why an increase in government expenditure reduces uncertainty. And this is not so obvious to me, at least ex ante, in what direction it should be going, because it could even be that too much spending could increase the probability of a recession in countries which have little space to begin with. Or we don't know if increases in government spending creates crowds in, crowd out, the private sector. It could be uncertain. So, I mean, there could be a lot of channels going on there, and it's not clear ex ante which one is affecting your results. So something that I was thinking of is some work that I have with Leonardo there and Francesco Zanetti and Hiroshi Morita, where we show that when a government announces a fiscal stimulus package, this creates a signal about the government opinion of the state of the economy. And we show that this signaling channel of fiscal policy is stronger when uncertainty is higher. But it could even be that when there is a strong signal, uncertainty in the economy goes down because the private sector look at what government does and extract information. So this could be potentially a reason why fiscal policy reduces uncertainty in the economy, but of course there might be many other ways through which this arrow works. So I just encourage you to explore a bit more. So to recap, we live in a nonlinear world, and we are trying to understand whether government spending has nonlinear effects, and whether in particular it shifts the distribution of output. And I think the contribution of the paper is really valuable, like to bring this like modeling tools that allow to make not only the mean, but also standard deviation and I guess skewness endogenous to government expenditure. And from that, we can understand that fiscal policy is more effective at stimulating the economy in the left tail of the output distribution. So I just encourage you to think a little bit more about the mechanism and the type of uncertainty that you are exploring, but I think it's a great change of perspective and very valuable contribution.
Okay, we have time for questions.
Thanks, Domenico. Very nice paper. So maybe two questions, I think, following up on what Anna was saying on mechanisms. I mean, as I was listening to you talk, I was thinking, I mean, are risk states actually exogenous or endogenous to fiscal policy? I mean, this is a really important point because, what happens if fiscal shocks themselves move spreads contemporaneously? And in that case, you're sort of destabilizing economic activity. And so how should we think about this? So there's another state of nature where it really depends upon initial fiscal space or initial levels of indebtedness, whatever that may be. But I think that's a really important mechanism. And the second thing I was thinking about is thinking about mechanisms is how should we think about, sort of the lack of monetary accommodation or the presence of monetary accommodation when fiscal is sort of reducing uncertainty. And you don't really obviously have this kind of a framework in mind, but I think digging a little bit deeper into these kinds of mechanisms could be very interesting.
Okay, the first part of my question was already asked, so I move to the second one, which is the following. Why not looking at inflation distribution? It seems very natural to me, even if you're not John Cochrane.
I have two questions. The first one is, so from the work of Nick Bloom and others, we kind of know like when uncertainty fades away again, you get sort of overshooting afterwards. So I was thinking like, I mean, is it not perceivable that what's going on is uncertainty goes up, spending goes up, and then when it seeds, then you get the large impact of it? Is that? So I'm just thinking about like how strong is the causal interpretation of what you're finding here. The second one, given that one of the authors is IMF, just like I'm allowed to ask about if I related to cross-country evidence, would this would seem to your evidence would seem to imply that countries with larger government spending would have less frequent recessions. But it's like, it seems to, I'm not sure whether that's true or not, but I would think it's not true, but it could be.
Maybe related to the last one, there is a literature on procyclicality of fiscal policy in developing economies, and also merged with more volatile, the perceived higher volatility of output of these countries. So this kind of suggests, could they be linked?
Shocks, so this, I mean, it's something different from procyclicality and countercyclicality. But one question is that, I mean, this series of fiscal shock, of course, have a variance. It may be that in periods of high variance of this fiscal shock, the effects are different with respect to period in which the variance is low. Maybe this is something that you can check in the data and capture somewhere, sometimes this idea that we have that sometimes fiscal policy itself is a source of uncertainty.
Okay, please. Yeah. You're going to go.
Okay, so yeah, if I stay here, I can see everybody. So thanks a lot. Thanks a lot for your comments and extremely valuable. So, and also to all the questions, I'll try to address all of them. So it's a lot. So the first one is, higher moments. So this is something I've learned starting thinking about risk. So I did a work on looking at the growth at risk, basically looking at in a predictive way at the predictive distribution of GDP. So I'm trying to predict GDP in the future and using a very flexible model, quantile regression or distribution regression that look at the entire distribution. And to our surprise, we realized that actually this very rich model can be captured just by looking at mean and variance. And the reason is the following, is that if you have a correlated mean and variance, it's equivalent to skewness. Okay, so you can have a downside, like as the chart was showing, as you noticed, if you have the mean going up and the variance going down, this is it's equivalent to skewness. So it's exactly observational equivalent. So that's why this location scale is extremely useful. So in the paper we also do this distribution regression or quantile IV and so on. So these are more complicated techniques, but the location scale capture everything, and we stayed in the location scale to keep the mechanism as transparent as possible. But that was an interesting surprise. So, but it's the fact that you might think, oh, it's Gaussian, like even a Gaussian, the model is Gaussian, right? How you can create a nonlinearity is really the simultaneity of mean and variance shift. So a Gaussian model with the mean and variance that are correlated can do a lot of wonders. That's the discovery I did. So the second point is, so you're saying other measures of risk? I would say the way people have been measuring risk, like VIX or financial risk, these things of Ludwigson, Eng, and so on. I wouldn't think about them as a measure of risk. In the end, risk is the distribution or the predictive distribution of GDP. So in a sense, that measures are either predictors of risk, the way I see them, either predictor of risk or symptoms of perception of people about risk. So from that point of view, so what we have to do here, it's actually, and I'm going to move to the second question that is about the mechanisms, actually the measures that are already there can be extremely useful to understand the mechanism around this. So you were highlighting a few mechanisms. I have my favorite mechanism instead is a little different, but we haven't explored in the paper, and it goes through financial stability. So basically what we have seen in predicting risk is that a very strong predictor of risk is financial conditions. The spread that Era was referring to, or VIX, or other measure of risk are extremely useful in predicting GDP. So what the policy might be doing here, that the mechanism we have to explore, and I think it's the one in action, especially in the big moment, is that fiscal policy is reducing the probability of getting into a deep recession. So it's sort of helping coordinating away from a bad equilibrium. So let me bring an example here, is COVID. So if you remember, COVID in May, it was April, VIX went to the roof. So VIX was higher than 50. The spread started going up. And then we had this, so in this situation, you can have two equilibria, basically. Either financial conditions go back to normal, or they stay bad, and then you have a collapse, as it happened during the great financial crisis. So what happened during COVID, that simultaneous coordination, which is also related to some questions before, simultaneous coordination of policy reduced, so fiscal spending, transfer, monetary policy accommodation, reduced financial uncertainty, financial risk, and helped coordinating to a good equilibrium away from a disastrous kind of situation. This is one of the mechanisms that we have to study, and a simple way to study is to looking at the effect of government spending on financial conditions. So that's, this is, right, fiscal space, all these, so there were questions about fiscal space by Era and by Morten about the cross-sectional implication of all this. So Morten, so you were saying, we should expect that the countries with a higher spending should have less recessions. Actually, here is not the level of spending. Here we are talking about the level of spending in particular situations. So I would change your question and say countries with timely and well-calibrated spending are those able to avoid deep recessions and so on. So, but that's extremely something that we have to do, extremely valuable. And also Era was referring to fiscal and monetary coordination. So looking at, I think we are just scratching the surface here by looking at the effect of policy on uncertainty. So people have been thinking about uncertainty always as exogenous. So what we are discovering today is that it's endogenous. Policy can affect it. So, and then it opened the question like, why don't we do this with monetary policy? And why don't we do it with monetary policy, coordinated or not, with fiscal? So these are all things that we need to explore here. I think, Adrian, you had a question on low-income country and developing, absolutely. And so Adrian and David have been building a fantastic data set of fiscal shocks for the world. So here up to now, there was a limitation. All these fiscal shocks were just for US and a few other countries. So David and Adrian have been constructing using large language models, a fantastic series of shocks from the 50s, quarterly for all the world. So I look forward to apply this to this setting. Oh, important, yes. The last question was, so here, actually, what we are looking is, the model is a sort of linear. So like we are looking at the linear effect on uncertainty, okay? So meaning that we are, if you remember the equation, we had like the standard deviation depends linearly on the level of spending, right? But there you can generalize it, okay, and go even further and think about the nonlinear effect there. So for example, instead of doing a linear regression, we can do an Adayara-Watson or a nonlinear regression. In that way, we are gonna get a nonlinear effect of G on the entire distribution, okay? So that's another important step that we need to take. Yeah. But thank you very much for your comments. Thank you.
Thanks to all the speakers for the wonderful session. And it's time for lunch, so I will ask you to gather back at 2:15. Thank you very much.